Hello. Okay. Mm, everything looks right. Um, yeah, I want to learn Godot and do a game. I said that before, but now I'm probably actually doing it. Um, we're first gonna read through the docs a bit. I did watch several long videos of people doing games in Godot the last days, and I didn't feel like streaming how I watch the videos for, I don't know, hours and hours. So I feel like I have an overview of how it works. Um, but yeah, now I wanna just read a bit through the instructions and get maybe some detailed info that were not in the video, and then we'll just follow this tutorial because um I really liked other videos of him I saw with the way he explains stuff and how he codes. Where there are other videos I opened already to maybe also do, um, but I'm not sure how much I like their style. And he to me feels like having a coding background and following patterns that I would also follow from a programmer perspective. And I have not been. I mean, I don't get angry if others don't, but I always like when I see other videos and they don't do it and just instantiate everything in the methods and stuff like that. I I don't like it that much. So yeah, I hope I will love this video. I don't like the art style of the package used. I like this way more. So yeah, we'll see. They are like really long, right? 8 hours, 7 hours. So we'll see how far I get today with just the first one. Especially when I'm following the tutorial all by myself. It's probably more than double the time, I would assume. Um, so yeah, I'll read through the docs to this video, and then this video also, just because of this style, um, I thought will be more helpful because it will be more motivating for me, because I like the result and I like to have this farming game as a result. So I'll see how I feel after the first one if I want to do this too. And then this is just really long, and I felt like it was very detailed and catches topics like shaders and all of that, and lighting and like bunch of interesting stuff. But it's super long, and it's for, I think, the um not the 4.3 version. So I'll have it for now. I don't know if I want to do it or not. Maybe those topics I specifically searched them, but this also I felt was really, really interesting. So yeah, I guess we'll start. I hope I won't fail too much. I have free for all this month, so, and starting from Christmas, so I haven't coded in a while. From work coding, normal programming. So we'll see how embarrassing it will be when we get to that. But yeah, I guess I just read out loud everything now. And then we'll see when I get bored by the documentation. Can I zoom in a bit more? Maybe like this should be good. Okay. And if anything is not visible, please tell me, because later I will have, let me show, I will have the screen like this for the YouTube tutorial. So it will be kind of like that all the time. So if I hide anything accidentally, just tell me. But okay. Yeah, let's start. Page is up to date for, oh, also if like music is too loud compared to my voice, which it looks like it is actually. It should be just as loud as me, which is not what I want. Let me check. Sometimes the microphone is not on full loudness for some reason. Oh, well, it was not full on the scale. Great. Now it should be better. Okay, yeah, the peak looks right where it should be, and the music is quite a bit below that. So I hope this is fine compared to the music loudness. Because I also haven't streamed with music for a while because I only did the gaming where I don't have additional music on. Okay. I hope everything is set up now. So I'll start reading. Up to date for 4.3. Godot documentation is available in various languages and versions. Expand the Read the Docs panel at the bottom of the sidebar to see the list. Now we'll stay with this. I think the stable should be 433, which is what I want. Oh, also if I read badly, not good, fail to read or talk, please don't mind. Reading is not my best skill, I would say. Okay. Welcome to the official documentation of Godot engine, the free and open source community-driven 2D and 3D game engine. If you are new to this documentation, we recommend you read the instruction page. Will do. To get an overview of what this documentation has to offer. The table of contents in the sidebar should let you easily access the documentation for your topics of interest. You can also use the search function in the top left corner. Get involved, we don't need that. Offline documentation, I think we don't need that. Is there a next button? Yes. Okay. Okay, introduction. Function. Oh yeah, we use Godot script. How's that language called again? Is it written somewhere here? No, doesn't matter. We will use the script language of Godot because it looks nice enough, and the only thing I hate about it is that it's Python style. No determining everything by indentation. I don't know, which I hate because I like to just write inline everything, add all the signs that are needed, and then it auto formats on save and it looks good. And now I have to actually press tab and stuff like that, which I'm not used to, so we'll see how that goes. But yeah, other than that, it looked really good. We'll always use static typing because I like that way more. And other than that, it just nice simplified language. So I hope it can do everything I want to do. So we'll see. But probably it will. And else we just switch to C++ if we need to do something special because I'm good at that. So yeah. Welcome to the official documentation of Godot engine. Oh, I also don't know how to say it, but I'll just say it like that. Godot would be how I read it as German mind, but I don't know. The free open source community driven 2D that we read already. Restriction whatever, ping overview before you start. The tutorial and resource page lists video tutorials contributed by the community. If you prefer video to text, consider checking them out. Otherwise, getting started is a great starting point. In case you trouble with the tutorials of your projects, one of the tutorials or your projects, you can find community channels, Discord, forums. Okay. Okay. I haven't looked at these yet, but I think I'll just skip that because I like what I found, I think. About the engine. A game engine is a complex tool and difficult to present in a few words. Here's a quick synopsis, which you are free to reuse if you need quick write-up. Yeah, I don't need that. Organization of the documentation, about concerns, introduction information, getting started information for beginners like me, manual, references needed in order. It contains feature-specific tutorial and documentation. So is this where I find like anything specific, right? Input handling. Okay. Contribution, community. Oh, class reference is the most specific. Okay, but as far as I know, we can access this right from the editor. Though I will be using Visual Studio Code for editing, so we'll see if we can just get all the information there too. But good to know where we get these detailed information if we need. Okay. It's written by the community. Have fun reading and making games with Godot engine. I hope I will. Why is this popping up all the time? Can you not? Thank you. So where are we now? List of features. Wait, that was the introduction. Okay, list of features. Might skip this one. Okay, system requirements, editor, features. Oh, GD script was the name. Yeah, I think we can even debug in Visual Studio Code. I did the setup for those parts, so we'll see how that goes. Tree editor, script editor, external script. Oh yeah, it's written here. I just skipped exactly that line. Yeah, we'll do exactly this, including the debugging. And then we'll see if we need anything else. Live reloading, scene editing, remote inspector. I was thinking about using Godot 4.4 dev version 7 to have the live preview of what the camera sees, but I think we can live without that, and I rather be on exactly the version the tutorials use, so that I can really follow step by step and not fail because something is different, which is also why, although I love the details that I saw here, because I don't think this is for 3, I will not use that as the main source. Okay, plugins. Editor plugins can be downloaded from the asset library to extend your editor functionality. We'll do without that for the start. Create your own plugins. Don't need that for now. Download projects from the asset library. Okay. Rendering. Forward plus rendering over Vulkan. Vulkan compatibility 3.3. I think I'll go with mobile for the most part. I'm not sure if mobile can also do web, but as far as I read, it cannot from the short introduction, because this explicitly states somewhere web here. Used by default on web platform. Because that's like getting people to download a game and play is a different thing than just hosting it on itch.io and they can play right in the on the website. So I'll see that I'll in the end use this, but I don't even know if that's actually necessary or this can do it too. I wouldn't know that Vulkan runs in the web, so it should be this we need. Yeah, and then we'll do 2D for most things, I guess, just because I'm better with creating, or not better, because I can create art in 2D, but I can't in 3D. So we go with that. Sprite polygon line rendering, high-level tools to draw lines with polygons, such as Parallax layers, 2D lighting, normal maps, specular maps. Anything interesting? Font rendering? Nah. GPU-based particle system. Tile map layers. 2D pathing. Okay, physics. Yeah, we'll learn about that in a tutorial, I think. 3D we can skip. 3D we can skip. 3D we can skip. 3D tools, physics. Okay. Custom vertex, fragment, and light shaders. I definitely want to go more into shaders at some point because I did a really small shader when I was at university, but I forgot everything and it was quite interesting. So I want to do more of it at some point, but I don't know anything because I forgot it all. Oh yeah, and they have the visual shader thing, which I also watched like one info video. Scripting. Object oriented signal group. 1 second. Okay. Did I unmute myself? Yes. A package just arrived. Oh, I need to later remember to enable Chrome audio, else you won't hear it. Ah, do I though? I don't know. That's for later. Let's go back here. There. Scripting, object-oriented, signals, groups for communication, cross-language, many algebra stuff, okay? And then we'll do GD script. We'll use static typing. Yeah, we don't like that it's Python inspired. We'll get syntax highlighting and all that in Visual Code, which is nice. And yeah, so we'll see. I would have liked it to be TypeScript inspired. That would have been nice for my personal preference. C# we don't need. Audio I have no idea anyway, so we'll need to read into that at some point. Import. Input mapping system using hard-coded input events and remapping input action. Keyboard input. Mouse input. Okay. Navigation. A-star algorithm in 2D. Okay. Yeah, we'll see how that goes. The game I want to make, I'm not sure how I'll do the stuff I want to do with it, because the creatures should interact and do their stuff kind of autonomously, I don't know. And yeah, I don't know how that would work. They would need to slowly create their mesh and only like know the places they went before and not know the entire area they can go, and kind of learn the mesh and build the world they know. But that's all stuff so far in the future. I'm not sure if I'll ever reach that point, so doesn't matter for now. Okay, the networking, well, it has that, so not needed for now. Internationalization, not needed. Windowing and OS integration. Spawn multiple independent windows with a single process. Move resize, window title icon, full screen mode. Okay. Mobile XR UI. Okay, UI is also interesting. Godot UI is built using the same control nodes, Godot's. I think Godot's engine UI, right? Control nodes used to make games in Godot. The editor UI can easily be extended in many ways using add-ons. Nodes, button checkboxes. Okay, this is just a list of stuff that you can do. Stack, grid, flow. Similar to auto, but is it, or how's the name of that? I always forget that. For web, I like to use that most. It's something flow. Damn. I'll find out when I need it. Flexbox, I think, is it, right? I think Flexbox is what I'm like most when doing web stuff. Theming, animation, file formats. Video playback is nice. C++17, okay, that's also nice. Though I will never need to edit anything in the engine probably. Okay, next, system requirements. Yeah, definitely nothing I care about. Come on, skip. Frequently asked questions. This pops up every time, so annoying. Do we go through these? Why not? I can just like read the question for myself, and then if I think it's interesting, we'll read it. Maybe I'll read it out loud. What can I do with Godot? How much does it cost? What are the licensing terms? Not interested. Which platforms are Godot supporting? Not interested. I think everything but consoles and those you can do with external companies. Which ones are supported? Not interested. What is GScript and why should I use it? What are the motivations behind creating GScript? Oh, that's interesting, but I don't know if relevant. In the early days, the engine used Lua scripting. Lua can be fast thanks to Lua JIT, but creating bindings to an object-oriented system by using fallbacks was complex and slow and took an enormous amount of code. After some experiments with Python that also proved difficult to embed, after some experiments with Python that also proved difficult to embed. The main reason for creating a custom scripting language for Godot were poor threading support in most script VMs, and Godot uses threads. Poor class extending support in most script VMs, and adapting to the way Godot works is highly inefficient. Many existing languages have horrible interfaces for binding to C++. Resulting in a large amount of code, bugs, bottlenecks, and generally inefficiency. We want to focus on great engine, not great number of integrations. No native vector types, resulting in a highly reduced performance when using custom types. Garbage collectors result in stalls and unnecessary large memory usage. Difficulty integrating difficulty integrating with the code editor for providing code completion, live editing, and all that. GDScript was designed to curtail the issues above and more. Okay, interesting. So it's just like, we needed to as a statement, right? Interesting. Which is a good design thing, right? If they only do stuff like that, creating their own language if it's actually necessary. That's a good philosophy, I think. Which programming languages is fastest? Sure. Be faster than C++ using GD extension will almost always be faster than either C# or GDScript. However, C++ is less easy to use than C# or C script and is slow to develop in. Yeah. Depending on how long I will stick to this project, usually I just stop projects way too quick. We might get at that point that we need that though, because I want to do some interesting calculations and procedural creature generations, so I'm not sure how efficient that will be in GDScript, but I don't know. Maybe it's just spawning some special nodes for a skeleton or something, and the engine does the rest. I have no idea how that will work. 3D, I don't care. Will be supported, I don't care. How can I extend? I don't care. How do I install Godot editor on my system for desktop integration? I think I installed it already. Editor, portable application. Why does Godot prioritize Vulkan over GDL and DirectX? Godot aims for cross-platform compatibility and open standards first and foremost. OpenGL and Vulkan are the technologies that are both open and available on nearly all platforms. Thanks to this design, a project developed with Godot on Windows will run out of the box on Linux, macOS, and more. With Vulkan and OpenGL remain our primary focus for their open standard and cross-platform benefit. Godot 4.3 introduced experimental support for Direct 3D12. This edition aims to enhance performance and compatibility on platforms where Direct 3D12 is prevalent, such as the Windows and Xbox. However, Vulkan and OpenGL will continue to as the default rendering backends for all platforms, including Windows. Why does Godot aim to keep its core features set small? I don't care. How should assets be created and handle multiple resolution and aspect ratios? Let's read that one. This question pops up often, and it's probably thanks to the misunderstanding created by Apple when they originally doubled the resolution of their devices. It made people think that having the same asset in different resolutions was a good idea, so many continued towards that path. That originally worked. I thought I heard someone. Where was I? That originally worked to a point and only for Apple devices, but then several Android and Apple devices with different resolutions and aspect ratios were created with a very wide range of sizes and DPIs. The most common and proper way to achieve this is to instead use a single base resolution for the game and only handle different screen aspect ratios. This is mostly needed for 2D, as in 3D it's just a matter of camera, vertical and horizontal FOV. Interesting. I don't know if I fully get that, but also not sure how important that would be for me. Choose a single base resolution for your game, even if there are devices that go up to 1440p and devices that go down to 400p. Regular hardware scaling in your device will take care of this at little or no performance cost. The most common choice are either 1080p or 720p. Keep in mind that the higher the resolution, the larger your assets, the more memory they will take, and the longer the time it will take for loading. Use the stretch option in Godot. Canvas items stretching while keeping aspect ratio works best. Check multiple resolution tutorial on how to achieve this. Okay. Determine minimum resolution. I think we don't read that. If I ever need it, I know that there's some tutorial for it. Next release. Oh, that's interesting. For the 4.4, right? Wait, when is the next release? It's the same question. Okay. And they are not giving an answer. Damn it. Okay. Which Godot version should I use for a project? Should I upgrade my project to use a new Godot version? I could like tribute. Have great idea of Godot. How can I share it? It's possible to use Godot, create a non-game application. Yes. I mean, they built their entire engine, right? So you probably can. Is it possible to use Godot as a library to use with its editor? Recommend you give it a try, as it will most likely save you time in the long term. There are no plans to make Godot usable as a library, as it would make the rest of the engine more convoluted and difficult to use for casual users. If you want to use a rendering library, look into using an established rendering engine instead. Keep in mind, rendering engines usually have smaller communities compared to Godot. This will make it more difficult to find answers to your questions. I'm kind of happy with using Visual Studio Code and be able to edit everything there. The only thing I saw so far that wasn't how I liked it was that people use the UI to connect signals and slots, which I like. Either I do it with the UI and then I see if maybe in some scene files I will find the line where it's written down. I just want to have it in one spot that I can find so I exactly know what is connect to what. But so far as I saw, there are also ways to directly connect them in code or in the script. So I'll probably do that. And with that, I feel like using a library actually. Yes, you do the placement of, like you compose the scenes in the UI, but everything but the composition I can just do in the editor, I think. What user interface toolkit does Godot use? Godot does not use a standard UI toolkit like GDK, Qt, or WX widgets. Instead, Godot uses its own user interface toolkit rendering using OpenGLES or Vulkan. This toolkit is exposed in the form of control nodes, which are used to render the editor. These control nodes can also be used in projects from any scripting language supported by Godot. Okay. This custom toolkit makes it possible to benefit from hardware acceleration and have consistent appearance across all platforms. On top of it, it doesn't have to deal with LGPL licensing caveats that come across with GDK or Qt. Lastly, this means Godot is eating its own dog food, since the editor itself is one of the most complex users of Godot's UI system. This custom UI toolkit can't be used as a library, but you can still use Godot or create non-game applications using the editor. See how I like the UI stuff. Don't know how much UI I need to do, but yeah, Qt, we use Qt with QML, and that's just a pain. So I hope this will be better. Why does Godot use the scons build system? I think I don't know that one. That's light, or bright rather. think of it as an improved cross-platform substitute for the classic make utility. I just would like the comparison to CMake, because if they use C++ anyway, I don't know why you wouldn't use CMake. But I don't know this one, so maybe it's actually better. Godot can be compiled for a dozen different platforms, mobile, many, WebAssembly. Developers often need to compile for several other platforms at the same time. Will never break a build. Oh, I don't even know if it's on the same level as CMake. Maybe it's more like Ninja. Because I use CMake Ninja combination, which might be then combined what this does. Prism is not simple. Several files are generated by code binders, shaders. Godot build process makes heavy use of cross-compiling tools. Okay. At least a little familiar. No, we don't build ourselves. Why does Godot not use STL? Oh, interesting, they don't. Like many other libraries, Godot does not make use of STL, with a few exceptions such as threading primitives. We believe STL is a great general purpose library, but we had special requirements for Godot. STL templates create a very large symbol, which results in huge debug binaries. We use few templates with very short names instead. Most of our containers cater to specific needs like vector, which uses copy on write, and we use to pass data around, or the RID system, which requires O1 access time for performance. Likewise, our hash map implementations are designed to integrate seamlessly with internal engine types. Our containers have memory tracking built in, which helps better track memory usage. For larger arrays, we use pooled memory, which can be mapped to either a pre-allocated buffer or virtual memory. We use our custom string type, interesting, as the one provided by STL is too basic and lacks proper internationalization support. Yeah, I guess only in C++20 they'll start. I mean, I don't know if about internationalization support, but a lot of things are very basic till 20, and the code page and stuff like that only got in there, I think, and will be improved after in the next versions. But interesting. On Qt, the thing I most hate is their custom types when debugging, but this will maybe be better. I don't know. I don't use the Qt editor, where maybe the debugging is better, and in Visual Studio Code it just sucks with my setup. Yeah, so we'll see. I hope we can just look into what stuff is, and they don't hide away everything like Qt does in private subclasses. Why does Godot not use exceptions? Interesting. We believe games should not crash no matter what. If an unexpected situation happens, Godot will print an error, which can be traced even to script, but then it will try to recover gratefully as possible and keep going. Additionally, exceptions significantly increase the binary size of the executable and result in increased compile times. Oh, I misunderstood that. I just read it as like error handling, which makes no sense that they wouldn't have it. Yeah, okay, I can see that. Exceptions that are just thrown and caught somewhere entirely else, I don't like anyway. The Java way I despite. So I wonder what then their error handling will be, actually. But I'll find that out at some point. Entity component system. Godot does not use an entity component system and relies on inheritance instead. While there is no universally better approach, we found that using an inherited-based approach resulted in better usability while still being fast enough for most cases. Okay. That said, nothing prevents you from making use of composition in your project by creating child nodes with individual scripts. These nodes can then be added and removed at runtime to dynamically add and remove behaviors. More information about Godot design choices can be found in this article. Yeah, I think I'll use a lot the composition way because I don't think there's multiple inheritance. And while multiple inheritance has its own problems, I don't like full inheritance where you need to redesign the entire code just so that your inheritance patterns work. So with multiple inheritance and then just doing interfaces which the stuff implements, I like that approach. If talking C++, I mean other languages just have interfaces which are always fine but still have singular inheritance, I think. So yeah, we'll see how that goes and how the composition works there. As far as I saw, it felt like it was similar, like a mix of interface and composition, because you state the class that you want to have in there, but then you need to set up and implement stuff of it or some parts of it. But I'm not sure if I saw that correctly. Maybe I need to do it myself just to fully get how their composition works. Maybe you also only put in several parameters, and the class that you use for composition must be fully functional, and you don't change the node's behavior or implementation, just the parameters. Okay. Why does Godot not force users to implement DOD, data-oriented design? Well, Godot internally attempts to use cache coherency as much as possible. We believe users don't need to be forced to use DOD practices. DOD is mostly a cache coherency optimization that can only provide significant performance improvements when dealing with dozens of thousands of objects, which are proceded every frame with little modification. That is, if you are moving a few hundred sprites of enemies per frame, DOD won't result in a meaningful improvement in performance. In such cases, you should consider a different approach to optimization. The vast majority of games do not need this, and Godot provides handy helpers to do the job for most cases when you do. If a game needs to process such a large amount of objects, your recommendation is to use C++ and GD extension to performance-heavy tasks and GD script for the rest of the game. Yeah, we'll see if we ever reach stuff like that. I do not expect that, I think. How can I support Godot development and contribute? Who is working on Godot? License. As far as I heard, you can do all you want. And I'm not intending to sell anything anytime soon, so, you know. Don't care for this. Changelog. Don't care for this because the 4.3 we will learn, and then we only need to check this when something new comes out. Yeah. Okay, so let's skip to getting started. This series will introduce you to Godot and give you an overview of its features. In the following pages, you will get answers to questions like, is Godot for me? What can I do with it? And more. Introduction to Godot. This article here, This article is here to help you figure out whether Godot might be a good fit for you. We'll introduce some broad features of the engine, give you a feel of what you can achieve with it, and answer questions such as what do you need to get started. I think we'll skip part of this because I don't know if I want to read all that again, which I already saw in the videos. What can the engine do? A lot. How does it work and look? Where is the button I want to see? I want to click. Where is banning? Here. Okay. How does it work and look? Godot comes with a fully fledged game editor, integrated tools. Of course, if you prefer, you can work with external programs. You officially support importing 3D scenes designed in Blender and maintain plugins to code in Visual Studio Code and Emacs for GDScript and C#. You also support Visual Studio for C# on Windows. Even Visual Studio, that's crazy. Okay. I would expect that'd be a huge effort, but maybe Microsoft is helping out there and supporting that to be an option for the engine. Programming languages we already read. What do I need to know to use Godot? In Godot, you can write code using GDScript and C# programming language. If you're new to programming, we recommend starting GDScript because we designed it to be simpler. GDScript is language specific to Godot. The techniques to learn in your browser with GDScript app. No, thank you. No, thank you. Key concepts. I guess we read that after drinking a bit. Every game engine revolves around abstractions. You use to build your application. In Godot, a game is a tree of nodes that you group together into scenes. You can then wire these nodes. Wire these nodes so they can communicate using signals. These are the 4 concepts you will learn here. We are going to look at them briefly to give you a sense of how the engine works. In the Getting Started series, you will get to use them in practice. I don't know if I want to do the first game to be here or just start with that, but yeah, we'll see. In Godot, you break down your game into reusable scenes. I find that so weird of a name. It reminds me of OBS scenes, and it just doesn't feel like that's... I don't know. If you do a player character or a mob or something and reuse that would also be a scene, where it's more like, to me, it's an object or a node or something like that, and not a scene. But I don't know. They probably have reasons for that name I just don't get. A scene can be a character, a weapon, a menu in the user interface, a single house, an entire level, or anything you can think of. Godot scenes are flexible. They fill the role of both prefabs and scenes in some other game engines. You can also nest scenes. For example, you can put your character in a level and drag and drop a scene as a child of it. For me, like, from a React perspective, I think it's just components, right? It could be just anything you compose into a thing, and it can have its own hierarchy. And if you drop something onto a level below, it's now the child of it. So if that level maybe like needed a subcomponent that's of a type player, then that would work because it's in the hierarchy. So whenever they say scenes, I just think component, and I hope that will work. And then also nodes, in my perception, are just also components. So it's kind of like a pre-built component, right? And then a scene is a component you use in the editor. But I don't know. I don't get the differentiations between those two fully. A scene is composed of more than one or more nodes. Nodes are your game's smallest building blocks. Maybe they are just component leaves that you arrange into trees. Here's an example of a character's node. It is made of a character body 2D node named player, a camera 2D, a sprite 2D, and a collision shape 2D. The node names end with 2D because 2D, you sure? I don't care. Notice how nodes and scenes look the same in the editor. When you save a tree of nodes as a scene, it then shows as a single node with its internal structure hidden in the editor. Godot provides an extensive library of base node types you can combine and extend to build more powerful ones. So maybe... Nah, I don't know. So it's the same name. And if you're editing it, it's called scene. If you add this player thing to another scene, it's called node. I know, confused naming. Godot provides, we have that. Scene tree. All your game scenes come together in the scene tree, literally a tree of scenes. As the scenes are trees of nodes, the scene tree also is a tree of nodes, but it's easier to think of your game in terms of scenes as they can represent character, weapon, or I don't know. I'll think of components. Signals. Nodes emit signals when some events occur. This feature allows you to make nodes communicate without hardwiring them in code. It gives you a lot of flexibility in how you structure your scenes. Signals are Godot's version of observer pattern. You can read more about. For example, buttons emit a signal when pressed. You can connect to this signal to run code in reaction to this event, like starting a game or opening menu. Other built-in signals can tell you when two objects collide, when a character or monster entered a given area, and much more. You can define new signals tailored to your game. Summary: node scenes and scene tree and signals are 4 core component Godot in Godot that you will manipulate all the time. Yeah, I don't know. It's just components in the first part and then signals for me. This is just all the same. Nodes are your game's smallest building blocks. You combine them to create scenes that you then combine and nest into scene trees. You can then use signals to make nodes react to events in order in other nodes or different scene tree branches. After this short breakdown, you probably have many questions. Do we know? I don't. Look at the interface, project manager. Asset library, settings. Don't care for 3D. Oh, this toolbar changes based on the context of the selected node. Here is the 2D toolbar, here is the 3D one. Okay. The explanation what these nodes do would have been interesting to me, but the rest is not. Let's look at the docs. The Python doc lists your project files, including scripts, images, audio samples, everything. Yeah. Scene, inspector, bottom panel. Sitting below the viewport is the host for the debug console. Okay. Yeah, we learn that when we use it. I don't think this is something I want to know from the start. 4 main screens. Oh yeah, those 4. We'll probably only use 2D because when we go to scripts, we go into Visual Studio Code. 3D we don't use. Asset library for now we also won't use. Dice syntax Godot 4 script. What is that? Sounds interesting. Integrated class reference, F1, okay. I hope that works with my shortcuts that I use in Visual Studio Code, that I don't need to relearn my bindings. Search help. Yeah, I hope I can just like usually jump into it, and else we'll find a way to do that. Okay. Yeah, we'll use the manual to search for stuff if we want to. I hope I already think like a programmer as I'm doing it as my full-time job. Sure, stuff. Next. Godot design philosophy. Now that you've gotten your feet wet, let's talk about Godot's design. Every game engine is different and it fits different needs. Not only do they offer a range of features, but the design of each engine is unique. Yeah, I want to know your design, not general. Oh, this is interesting. Okay. Yeah, that's stuff I want to know. I think that might be the most interesting so far from everything before. Let's see. Object-oriented design and composition. Godot embraces object-oriented design at its core with a flexible scene system and node hierarchy. It tries to stay away from strict programming patterns to offer an intuitive way to structure your game. For one, Godot lets you compose or aggregate scenes. It's like nested prefabs. If you can create a blinking light scene and a broken lantern scene that uses the blinking light. I don't know what nested prefabs are, so maybe that's a problem here. Then create a city filled with broken lanterns, change the blinking light's color, save, and all the broken lanterns in the city will update instantly. But that is only if I define the color inside the broken lantern, right? If I would define the broken lantern color as an extern, then it wouldn't change. Or maybe the default, right? If I have a default with the extern and don't override the default, it will work, as far as I understood. But it's still separate instances of the broken lantern. and not just one class used everywhere. At least I think. On top of that, you can inherit from any scene. A Godot scene could be a weapon, character, an item, a door, a level, part of a level. Anything you'd like. It works like a class in pure code. Okay. Except you're free to design it by using the editor, using only the code, or mixing and matching the two. It's different from... I should just check this once. To understand. And because of the words in the word, I might want to open it in another tab. It's so bright. I'll just quickly read and then think and say something maybe. It's different from prefabs you find in several 3D engines, as you can then inherit from and extend those scenes. You can create a magician that extends your character, modify the character in the editor, and the magician will update as well. It helps you build your project so that their structure matches the game's design. Wait, how would it work with prefabs then? Would it not update? That would be horrible. Or I guess maybe they use full composition then, so you would have wait, move, jump as a moving instance, and then you would add that to the wizard, add that to the warrior, and then do the specific implementations, and then you could still use the wait, move, jump movement prefab and added that, and everything would change, but you couldn't use inheritance to like build a full character and then advance that. Maybe something like that is the difference. Also note that Godot offers many different types of objects called nodes, each with a specific purpose. Nodes are part of a free tree and always inherit from their parents up to the node class. Although the engine does feature some nodes like collision shapes that are parent physics that a parent physics body will use, most nodes work independent from one another. In other words, Godot's nodes do not work like components in some other game engines. Now I don't know if components, I was talking about React components. I don't know how components in other game engines work. Sprite 2D is a node 2D, a canvas item and a node. It has all the properties and features of its three parent classes, like transformations, or the ability to draw custom shapes and render a custom shader. Okay. I like this very much, actually. All-inclusive package. Godot tries to provide its own tools to answer most common needs. It has a dedicated scripting workspace. and an animation editor. A tilemap editor, a shader editor, a debugger, a profiler, the ability to hot reload locally and on remote devices, etc. I don't know how. Oh, maybe for the tilemap. I was wondering how this picture maps to the explanation. The goal is to offer a full package to create games and a continuous user experience. You can still work with external programs as long as there is an import plugin available in Godot for it. You can create one like the tilemap importer. I use Synfig Studio for my animation stuff, so I probably cannot import that here. Let's do a quick research for that. Godot Synfig Studio importer. At least there are tutorials about it, so maybe it's actually possible. Importing animated bones into video game engines. Okay, I didn't expect that. I'm clearly looking at the other monitor, right? So we'll get back to reading in a second. Import SVG as a tree of path to D. Interesting. So I guess currently it would not work. Implement 2D vector graphics draw component. As of March 2023. And it's been rejected a few months ago. Here's a few reasons. It's CPU bound. Godot does not currently support vector graphics first party. Ending such support would create performance and long-term maintenance expectations among users who would expect it to work on par with the dedicated vector graphics game engine. It could be possible to implement this as a plugin if hooks are added to the 2D renderer and or if drawable textures are used for allowing generic shaders, math, blah 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 blah. Okay, so possibly at some point, but not yet. Or as an extension. Oh. Okay. I should add light, maybe. Nah, it's fine. It's not good, but I don't know. Maybe you do one less. Does it make any difference now? Oh, it does. Okay, let me stay like this. The other is too bright for me for today. I don't know. My nose is running a bit, so I don't want additionally bright lights in my eyes. So no SVG import. Sedge. The goal is to offer a full package to create. We read that already. That is also partly why Godot offers its own programming language, GDScript, along with C#. GDScript is designed for the needs of game developers and game designers and is tightly integrated in the engine and the editor. GDScript lets you write code using an indentation-based syntax, yet it detects types, and that's great, and offers static languages quality of auto-completion. It is also optimized for gameplay code with built-in types like vectors and colors. Note that with GD extension, you can write high-performance code using compiled languages like C, C++, Rust, D, Hex, or Swift without compiling the engine. I don't know what this is. The rest I kind of know, but this I never heard before. Note that the 3D workspace doesn't feature as many tools as the 2D workspace. You will need external programs or add-ons to edit terrain, animate complex characters, and so on. Godot provides a complete API to extend the editor's functionality using game code. I guess that's a state machine for some creature from a hero. Damn. Oh, a state machine editor plugin in Godot to by someone, Kubicek. It lets you manage states and transition visually. Interesting. Open source. I don't care. Community driven. I don't care. Editor is a Godot game. The Godot editor runs on the game engine. It uses the game's own UI. It can hot reload code and scenes. What? It uses the engine's own UI system. It can hot reload code and scenes. Oh, hot reload code and scenes when you test your projects or run game code in the editor. This means you can use the same code and scene for your games or build plugins and extend the editor. This leads to a reliable and flexible UI system as it powers the editor itself. With the add tool annotation, you can run any game code in the editor. I don't understand that. RPG is in a box is a something. Oh, okay. Put the tool annotation on top of any GDScript file and it will run in the editor. This lets you import and export plugins, create plugins like custom level editors, or create scripts with the same nodes and RP you use in your projects. The editor is fully written in C++ and is statically compiled into a binary. This means you can import it as a typical project that would have a project.godot file. I don't get that part. Let me check my phone real quick. Need to answer my mom. Why am I kind of... I don't feel sick, but my nose is running. That's so annoying. Yeah, I don't understand the tool thing. Maybe it just makes you be able to use other things, like in the context or something of the running program, but either we find out because someone uses it, or it's just not for our use case. No way, this was how it looked before. This is, or is it just the edition they built? Wait, let's see. I don't know. Okay, separate engines. Godot has dedicated 2D 3D engines. As a result, the base unit of 2D scene is pixels. Even though the engines are separate, you can render 2D in 3D, 3D in 2D, and overlay 2D sprites and interfaces over your 3D world. Okay. But I hope this means that the 3D engine can be used in the 2D engine and not that you get really bad 3D stuff because the 2D kind of supports it too. Step by step. Okay, we're getting closer to where we want to finish. And then do the video. And I think it's been... quite some time already, right? I feel like my timer in OBS is shown in hours and not in minutes. No, that would also make no sense. Maybe it's just buggy. Okay, step by step. This series built upon the introduction to Godot. Sure. The following lessons are preparing you for your first 2D game. Step by step, true necessary foundation is problem. Wait, didn't we read that already? Is it just the same, or is it more now? Should have just started reading here instead of the instruction, I guess. Okay. Notes are fundamental building blocks of the game. They are like the ingredients of a recipe. There are kinds of dice from notes. All notes have the following characteristics: a name, editable properties. They receive callbacks to update their frame every frame. You can extend them with new properties and functions. You can add them to another node as a child. The last characteristic is important. Together, nodes form a tree, which is a powerful feature to organize projects. Since different nodes have different functions, combining them produces more complex behavior. As we saw before, we can build a portable character, a playable character the camera follows using character body 2D node, a sprite 2D node, a camera 2D node, and a collision shape 2D node. I feel like let's read scenes first before I complain. When you organize nodes in a tree, like our character, we call this construct a scene. That's so weird. But fine. Once saved, scenes work like new nodes, types in the editor. where you can add them to a child of an existing node. In that case, the instance of a scene appears as a single node with its internal hidden. Scenes allow you to structure your game's code however you want. You can compose nodes to create custom and complex node types. Like, it's so weird. Scenes allow you to structure. You can create custom complex node types. So they literally here state that it's the same. A scene is just a complex node type. Great that they have different names. Like a game character that runs and jumps, a life bar, a chest with which you can interact, and more. Godot editor is essentially a scene editor. It has plenty of tools for editing 2D and 3D scenes, as well as user interfaces. A Godot project can contain as many of these scenes as you need. The engine only requires one as your application's main scene. This is the scene Godot will first load when you or a player runs the game. On top of acting like nodes, scenes have the following characteristics. They always have one root node, like the player in our example. You can save them to your local drive and load them later. You can create as many instances of a scene as you'd like. You could have 5 or 10 characters in your game created from your character scene. I wonder how this would work with the camera 2D and several characters, because we can't have, like, it can't work, right? I wonder what if the engine just refuses and says there can only be one camera, or for some reason chooses the first or last or something like that. Creating your first scene. Let's create your first scene with a single node. To do though, yeah, we don't do that now. Single label, add child node, label, cool. Changing no properties. Oh, this is interesting. You can move your label node in the viewport by selecting the move to. Okay. Oh, I thought they maybe explain all the buttons now, but they don't. Running the scene. Yeah, we can even run that from Visual Studio Code as far as I saw, or debug from there directly, which is nice. The save scene as dialog, like other file dialogs in the editor, only allows you to save files inside the project. The rest //. Path at your top of your window represents the project's root directory and stands for resource path. For more information, okay. Yeah. The editor saves the main scene's path in the project Godot file in your project directory. While you can edit this text file directly, you can change project settings from project settings window. Yeah, I when I set up Visual Studio Code, I already found this part and liked it a lot, that I could just fix the main scene location just in that file. Okay. Maybe now it gets more interesting. In the previous part, we saw things. We don't need to read that again. You can create as many scenes as you like and save them. Great. File from previous lessons. Sure. Things, more things. Once you have saved a scene, it works as a blueprint. You can reproduce it in other scenes as many times as you'd like, replicating an object from a template like this is called instancing. Yeah, that's what I earlier said when I meant that we have instances and not just the class directly. So if you would expose a property and change the color of the ball there, it wouldn't change everything, but if you would change the default color of the ball class, it shouldn't change for every ball. As mentioned previous, instance scenes behave like a node. The editor hides their content by default. When you instance a ball, you can only see a ball node. Notice also how each duplicate has a unique name. Every instant of a ball scene starts with a name, structure, and properties as ball something. However, you can modify each independently, such as changing how they bounce, how heavy they are, or any property exposed to the source scene. Okay, by the source scene. I was just confused why you could but this is the important part. In practice, let's use instantiating in practice to see how it works in Godot. We invite you to download the ball sample projects we prepared for you. Nope. Nope. Extract the archive. No. No, we don't need that. That's too simple. We are not gonna drag some balls in and then just click start to see them fall down. Okay. Editing scenes and instances. Change the properties of one ball without affecting the others using the inspector. Change the default property of every ball by opening the ball. Yeah. That's what I said earlier. Thanks, Doc. How is the name for documentation? Thanks, documentation? My English lacks, I don't know. Anyway, we thought of that before, so wasted our time again. Select the ball node in the inspector on the right. Click the physics material property to expand. Set the bounce property. Okay. Note. You may notice you are unable to change the value of the physics material of the ball. This is because physics material is a resource and needs to be made unique before you can edit it in a scene that is linked to the original scene. To make a resource unique for an instance, right-click on the physics material property in the inspector and click Make Unique in the context menu. Resources are another essential building block of Godot game we'll cover in later session. Oh, so this physics material itself was instantiated for the ball, I guess? And that's why you can't just replace it, because it's like a shallow copy. And they want to prevent you from changing it for every ball by accident, I guess. So you need to make a true full copy of that. At least that's what I interpret into this block. That's definitely interesting, because the resource, then I don't fully understand yet. Maybe it's just assets, and any asset. No, but it's more than just the asset. Is physics material also a node? I wonder. Or this is just saying a fixed node from a node or from a scene is called resource, and then you can't do that. I don't know. We'll probably find out when we run into this, but good to maybe remember this part, I think. Scene instances as a design language. Instead, instance and scenes in Godot offer an excellent design language, setting the engine apart from others out there. We designed Godot around the concept from the ground up. We recommend dismissing architectural code patterns when making games with Godot, such as model viewer controller or entity relationship diagrams. Instead, you can start by imagining the elements players will see in your game and structure your code around them. Yes, why not? I think. Why not? For example, you could break down a shooter game like so. Instanced by code. Yeah, makes sense, I think. So the weapon can shoot. Morning. I will say, compared to the Onu, you are a bit quiet. Either up the mic or oh, thank you. How do I say your name? Loki Trickster? Thank you so much. I wasn't sure earlier, and usually I don't have the music running, rather have in-game music or something like that. I hope this is better. Okay. And then sometimes, like, I use the same music program all the time, right? So if I change it because I want louder music, it breaks it for a stream, which is a bit annoying. But okay, if it's better now, that's good. And welcome in. Okay, yeah, for me that makes just sense, I think. It's how I think about the stuff anyway. But as I said earlier, it's more the component view I would have. So, yeah, I rather view these as just a composition of all the elements in the scene or the game I have. And then it's structured below that into the nodes and scenes and all of that. You can come up with a diagram like this for almost any type of game. Each rectangle represents the entity that's visible in the game from the player's perspective. The arrows tell you which scene owns which. Once you have the diagram, we recommend creating a scene for each element listed to develop a game. Programmers tend to spend a lot of time designing abstract architectures and trying to fit components into it. Well, then I'm not a programmer. I hate doing that. I'm just I don't know. I just want to do stuff as soon as I understand them. So I tend to read way too much before, watch too much videos, and then start, so I feel informed. But I rarely really design stuff, and I just go in, do them, fail, and repeat till they kind of work. Designing based on scene makes development faster and more straightforward, allowing you to focus on the game logic itself, because most game components map directly to a scene. Using a design based on scene instantiation means you need little other architectural code. Okay, here's an example of a scene diagram for an open world game with tons of assets and nested elements. Sure. Imagine we started by creating a room. Yeah, I don't think I need that. It's kind of, I think, intuitive to just structure stuff in things in my head while I do things. Have anything planned or just try to learn? I have a game idea I want to try, and I've done some Unreal Engine before, but never finished any project. And then now I have a new idea and want to do something, so I want to learn Godot first, and I want to do this thing as a first step to finish like a game in a sense, because I liked how they explained everything, and I liked how they structure their program and how they structure the script files. So I want to do this as a first step, but then when I'm done with these two, I want to do kind of like a mix of Tamagotchi and Terrarium. So I want to do procedural generated environment, procedurally generated creatures, and then kind of have a life cycle for that. So they eat each other and live and die, and you can like care for them kind of like you would with a terrarium or a pet or aquarium or something like that. So what I would need for that at some point is not use sprites and assets directly, but if you know Spore, I kind of, and this is like big dreams I'll never finish, right? But I kind of want to do it in a way like Spore does the creature creation. So you really freely create a creature, you design their properties, like do they eat plants or other animals? How far can they sense other things? Can they maybe only see? And then, all the pathfinding and that is behind that might get quite complex. I find that super interesting. So I want to go in that direction. But first step would be like reading this, doing this, and then probably just create one plant that grows and dies, one animal that eats it, and see if it kind of works like a life cycle. And that's like my plan for hopefully till end of January, because I don't work for this month. But I have no idea how close I will get. I mean, probably just doing these 2 tabs will take me several days. So I don't know. We should finish this today and start with this. That would be perfect. Nice. I'm actually making a VPad project based around the Digimon Tamagotchis. Ooh, that's also nice. With a focus of just one pet, right? And then you care for that and give it food, and it evolves. Or it's not called evolving, right? In Digimon. Digitation. That's cool. I kind of like my project idea is a bit broken still. It doesn't fully fit together, because if I have this life cycle idea, usually when you have projects like that, or programs or games, you simulate huge time scale, right? Because you want to see how the population grows and dies and changes, and maybe you do like genes so they change by themselves and, I don't know, grow a bigger nose or get more hungry. But if you have that idea, it doesn't fully fit with the idea of actually Tamagotchi VPet style, where you have one big creature. So I don't know how to combine that yet. I will find out when I do it. But probably maybe you can just take a box and say this creature lives forever, and then you create the environment it can live in, put it in there, and then just watch it and watch everything work or not work, and like interact a bit and help it. But yeah, the project is way too big, as I usually do, and then I never finish, but we'll see how far I get this time. You can give it food, drink, train, and it evolves depending on how it was taken care of. Oh, that's cool. That's really cool. Yeah, I like those. I know, I just like the idea of digital pets. I don't know. It's nice. If you kill them, no real pet would have died. But you still have like fun interaction and like satisfaction of caring right for it, right? And then have the evolution and stuff like that. What's your time schedule with that? Do you have like just the project idea, or already some, I don't know, something playable, or a planned date where you want to have something finished that is playable? Okay, let's continue a bit reading. Each of these would be a scene instance. Later we could create scenes representing guards and add them to the citadel. They would be indirectly added to the overall game world because it would be below the citadel. Sure. With Godot, it's easy to iterate on your game like this. All you need to do is create and instantiate more scenes. We designed the editor to be accessible to programmers, designers, and artists, a typical term development. Summary: the ability to divide your game into reusable components, a tool to structure and encapsulate complex systems, a language to think about your game project structure in a natural way. That's why I would just call the things components, but maybe the components term is in other used in other editors already that I don't know of, so probably that's why they didn't use it, to differentiate what it means, I guess. Next. I'm up to 70 different Digimon. Oh my god, that's a lot. It currently works with Twitch, where viewers can interact as specific at specific times. I want to finish the evolution path before I release it out to the world. Oh, that's interesting. If you have a link, you can post it if there's something I can check it out at some point or after stream. I know there's this Pokemon integration, but it's more where you catch it, right? And then you can use it to fight against other stuff. If you if you don't have planned that already, it would be also cool if you have the Twitch integration, you could show your pet on stream, you join the stream connected to your personal pet, and then you run on the stream in the bottom, but it's your personal pet and not just a random creature. Something like that would be cool. But I guess that's different integration than interact with the creature that's currently played by the streamer, right? Yeah, I'll check that out after. I made a short I made to show off the evolution. Okay. Yeah, I'll check that out after stream. That sounds really nice. What's your background? Do you directly jump into video games, or have you I don't know, professional programmer, something like that, artist? I find that always very interesting when someone is developing games. They can come from so many different directions. If you mind answering that. Of course, no forced to answer such questions. No prior experience. I started a Yugo and at Godot. Ooh. So you've learned the hard way and gone in directly. But I think with a concrete project you want to do, it's always easiest to learn because you just have motivation for that. Yeah, I hope it works out well and you'll be happy with the result you'll have in the end. Yeah, if you have any tips, I mean, now I'm not programming anything, right? But if you have any tips in general, let me know. I'll probably fail about so many things before I got anything going. I've made a few different projects. This is the one. This is just one of many. I see. That's cool. Yeah, I just need to get in a mode where I finish projects and not start and stop. That's my biggest weakness, I think. Okay, scripting languages. I'm not sure if there's anything valuable here, but we'll skip over it like before. Maybe just read the bold stuff. Script attached to a node, understand the behavior. Sure. Available script languages. We use GDScript. Which language should I use? GDScript. I think this is kind of what we read already in the introductions part. Object-oriented and imperative programming language built in Godot. It's made by and for the developers, so can use it in coding games. It features simple syntax, blazing fast compilation and loading times, tight editor integration with code completion for node signals and more information from the scenes it's attached to, built-in vector transform types, making it efficient for heavy use of linear algebra. A must for games. Supports multiple threads as efficiently as statically typed languages. No garbage collection, interesting. As this feature eventually gets in the way of creating games, the engine counts reference and manages the memory for you in most cases by default, but you can also control memory if you need to. Interesting. I think so far I have not used a language that is this high level as GDScript and not be garbage collected. So I like that, but maybe I'm wrong and I did have that and didn't realize. Gradual typing, yeah, I'll type statically all the time, definitely. GDScript looks like Python, that's the one thing I dislike. Okay, why don't we use Lua? We read that before that there were problems and they felt like they needed an optimized language. C# we can skip. C++ we might do because I'm good at C++ and if something needs to be fast, we'll probably do it there. Even though I'm not sure how efficient I'll actually be able to do stuff. Register method. Oh, this doesn't look too nice though. Why is it named? Oh, okay, maybe you register the methods for the events and hooks. I see. When you can use any version of a language, compiler as extension, sure. Okay, skip. I have a lot of projects I'm doing at once. I jump around between them. Oh, okay. I mean, as long as you making progress in them and not dropping them, that's fine, right? For me, the problem is not the too many ideas. It's more that I just drop a project as soon as I find something new. So that's just not the right thing to do. I should just finish stuff. But it's not just games, it's just general. If I do some animation stuff, very often if it's a bigger thing, I just don't finish it and drop it. But yeah, I do my best to not do that, but it's tough at times. Creating our first script. There's just a button we click, right? Attach script. Okay. GD script, C#. GD script, omit the line with the extend keywords. Your class will implicitly extend ref counted, which Godot uses to manage the memory. Okay. By default, the inspector displays a node's property in title case with capitalized words separated by space. In GD script code, these properties are in that format, which is lowercase with words separated by underscores. You can hover over any property name in the inspector and see the description. I love camel case, which is like this, right? Or this or that. So I will definitely use that if possible. I really dislike this style. I don't know. I just grew up with camel case naming. Hello world. Yeah, we can skip all of that. GDScript is an intent-based language. The tab at the start of, oh yeah, we know that. And I dislike it. Turning around, speed, angular speed. I think I only read the note blocks here, and then we can probably quickly go over the last part in the same way and then start the actual project. Engines in Godot work as radians by default, but you have a built-in function and properties available to you. Prefer to calculate angles in degree. Okay. Games work by rendering many images per second, each called a frame, and they do so in a loop. We measure the rate at which the game produces images. Yes. Come on. That's nothing I need to read about. The engine and game developers do their best to update the game world, render images at a constant time interval, but there are always small variations. Yeah, we have the delta, right? I read that already. Notice how process like init starts with a leading underscore. By convention, Godot's virtual functions, that is to say, built-in functions you can override to communicate with the engine, start with an underscore. Okay. In the code editor, you can control-click on any built-in property or function to open the corresponding documentation. In C#, we don't need for C#. Moving a node like that does not take into account colliding with walls in the floor. In your first 2D game, you will learn an approach to move objects while detecting collisions. There was the move and slide thing, right? This is probably just setting the new position. Yeah, okay. Okay, next. Listen to player input. Yeah, I saw that already in some videos I watched about Godot. You can see and edit input actions in your project by going to project settings, and clicking on the input map. I saw that before too. Yeah, processing. I don't know if I like this though, this way of processing inputs. I think I would rather do the like on input method function, set the direction. Just when you press the buttons or release the buttons, I determine the direction, and then in the processing I only use the direction that I have set. I think that's more of my style, rather than on every loop check which buttons are pressed. But I'm not sure if there's a reason for this being better or not. Okay. I think the summary we can read. In summary, every script in Godot represents a class that extends one of the engine's built-in classes. The node types your class inherit from give you access to properties such as rotation and position. In our sprite's case, you can inherit many functions which we didn't get to use in this example. In GDScript, the variables you put on the top of the file are your class's properties, also called member variables. Okay. Each file is one class, I think, if I want to translate it to C++. So these are member properties. Okay. Besides variables, you can define functions which for the most part will be your class's methods. Godot provides several virtual functions you can define to connect your class with the engine. These include process to apply changes to the node's every frame, and unhandled input to receive input events like key and button presses from the user. There are quite a few more. I think there's also process physics, which I don't fully know the difference between process and process physics, but I'll probably find out at some point. The input singleton allows you to react to the player's input anywhere in your code. In particular, you will get to use it in the process loop, instead of this. In the next lesson, using signals, we build a relationship between script and nodes. Let's quickly see if we'll get an explanation why it's better maybe to use one of them. The built-in input callbacks mainly that you have two main tools to process properties input in Godot. Like process, it's a built-in virtual function that Godot calls every time the player presses a key. It's the tool you want to use to react to events that don't happen every frame, like pressing space to jump. To learn more about input callbacks, see using input event. The input singleton, a type, is a global accessible object. Godot provides access to several scripts. It's the right tool to check for input every frame. I mean, with the interpretation, if it's still pressed, I understand it, but you could just like press down released, and then it wouldn't be an every frame check, right? Yeah, I have no idea when I should use what, sadly, from just this. But maybe it doesn't matter too much. Okay, signals. Oh, Hackhunter, nice to see you. Welcome in. Tech says, ask me anything. Will you be needing music in the future or whatever this project is? I don't know. Probably some background music and probably sounds for the creatures, though maybe I want to procedural generate the sounds too. But I guess the way you're asking, you ask if you want to provide music, or you kind of committed now that if I need music, you will do it for me, right? For free. At least that's how I read your message. There's an action just pressed, which is a single input where as is action pressed is mainly used for holding. Okay. So if it's something holding, I'll handle it in the process method directly. Okay, yeah, kind of makes sense that I only check in the frame if it's still held. Yeah, okay. Signals. Just one more chapter and we can skip through this and then finally follow the tutorial. Too much reading already. Using signals. In this lesson, we'll look at signals. They are messages that nodes emit when something specific happens to them. Like a button being pressed, other nodes can connect to that signal and call a function when the event occurs. Signals are a delegation mechanism built into Godot that allows one game object to react to the change in another without them referencing one another. Using signals limits coupling and keeps your code flexible. For example, you might have a life bar on the screen that represents the player's health. When the player takes damage or uses a healing potion, you want the bar to reflect the change. To do so in Godot, you would use signals. I pressed spacebar by accident. Like methods, signals are a first-class type since Godot 4.0. This means you can pass them around as method arguments directly without having to pass them as strings. Oh yeah, I saw that change. And I was so happy that I didn't try to start using Godot before 4.0. I would have hated to pass around strings for the methods. That's just, I don't know. I need my autocomplete and all of that. Otherwise, I can't function. I'm offering my services to make some music and sound design for this, yes, free of charge, trying to build a portfolio outside of my usual music. I'll definitely come back to you if I do be at that point where I need it, but like, trust me, it will be either month or forever until I'm at a point where it makes sense, right? But yeah, I'll definitely consider it. And I was joking about the free part, right? So if I actually like finish this and put it somewhere to play, I wouldn't want to have that done for free. I don't know, but yeah, we'll see if I'll ever get to a point where I say this game needs music now. It's kind of finished and there's a vibe I want to create that only music can. So yeah, I'll note that, hopefully not forget it. Like methods, signals, oh yeah, we read that. Yeah, I love that it's first class now. This means you can pass them around directly without having to pass them as a string, which allows for better auto completion and is less error prone. See signal class references for a list of what you can do with a signal type directly. As mentioned in the instruction, signals are Godot's version of observer pattern. You can learn more about in patterns. We will now use the signal to make our Godot icon from the previous lesson move and stop by pressing a button. For this project, we will follow the Godot naming convention. Classes nodes use Pascal case. Is Pascal case the same as camel case? Variables and functions use snake case. Nah, I'll go Pascal case anything, but the first letter will be small for methods and functions and variables. And constant use all caps. Yeah, that I also do. So we'll do a combination. I hope this is fine and it doesn't restrict us in some way with the naming. Scene setup. Okay, let's skip through things again. Create a button. Position it. Name it. Where's the connection? That's the interesting part, which I don't know if I want to do it via the UI or I rather want to define it in code to easier know what I connected in which scenes. Here we want to connect the button's press signal to our sprite 2D, and we want to call a new function that will toggle the motion on and off. We need to have a script attached to the sprite 2D node, which we do from the previous lesson. You can connect signals to the node doc. I was just messing up the words. You can connect signals in the node doc. Select the button node and on the right side of the editor, click on the tab Node next to the inspector. The doc displays a list of signals available on the selected node. Okay, so I select the button and then I see button press. Double click the press signal to open the node connection window. Yeah, and then this I don't get why I should do it in here. And I don't know where it's stored. Maybe it's stored in the session gd something file, which also would be fine. But I will try that out when I do this video. There you can connect the signal to the sprite2d node. The node needs a receiver method, a function that Godot will call when the button emits a signal. The editor generates one for you. By convention, we name these callback methods whatever. Here it will be this. Yeah, that I'm fine with. All the things that start with underscore can have that naming. When connecting signals via the editor's node doc, you can use two modes. The simple one will allow you to connect the node that have a script attached to them and create a new callback function on them. The advanced view lets you connect to any node and any built-in function, add arguments to the callback and set options. You can toggle the mode in the Windows bottom right by clicking the advanced button. Okay, so we can connect it more than just as a notify. This is just a notify, and with this we have basically a full function definition of how to connect and what data we want to transfer. If you are using an external editor, we will use code. This automatic code generation might not work. In this case, you need to connect the signal via code as explained in the next section. Interesting. But why would it not work? Don't I just edit the files that the engine generates? Yeah, we'll see if we'll struggle with that. Click the connect button to complete the signal connection and jump to the script workspace. You should see a new method with the connected icon on the left. Yeah. Oh, maybe we won't see that in Visual Studio Code. That might be. Replace with function body. If you click the icon, a window pops up and displays information about the connection. This feature is only available when connected nodes in the editor. Oh, I see. So if I connect them in code, I can't have this information. But I also wouldn't need to, because I can just search for the term and see where I connected, right? Let's replace the line with the pass keyword with code that will toggle the node's motion. Okay, process is processing. Yeah, I think that's just standard code of setting it and then changing that. Wait, but that's built in again. Another method of a node class is processing returns true. Oh, interesting. So we can stop a node from processing. I was about to say that there should be an if clause here if we want to process or not, but that's just built in. So you can turn on and off the nodes. Have you decided what kind of game this is going to be? Yes. So it will be like a Tamagotchi style thing, but you build the full environment, in my idea at least. So you'll like have an aquarium or terrarium, you have the full thing, and you have a life cycle, so that entire aquarium must survive. And then probably on top, I want to add that maybe you can have one creature you create that lives eternally. And so you can have a fast-paced life cycle with one big creature you care for, and then see that the entire environment works out and is sustainable. So the parts where music makes sense and fit would be like a general background music for intro and while playing the game, and then all the sounds that are used, I don't know how that will work, because I want to do it Spore-like. So if you remember how Spore had their creature creator, something like that I want for my creatures. Everything 2D. And not only the creatures, like monsters and plants, should all be in the same way, and then you define their properties so they behave accordingly. But in that way they also will make sounds, right? And there will be background environmental sounds, and I have no idea yet what I want to do and how I want to do it, because it's so much effort. Everything is so much effort already with the idea, right? That the best thing would be that dynamically the environmental sounds get created from the properties you choose. And then you just have a bunch of samples that get combined. And then, of course, on top, there would be some music to fit the aesthetics and vibe and all of that. But yeah, I don't know if I'll ever reach it and how I'll get there, and if I stray from the path to that idea. But that would currently be the idea. So kind of Spore-like procedurally generated stuff, 2D. You create the entire environment in a way that it will probably be self-sustainable, but then you interact with it and try to make sure that everything runs smoothly, and if something dies you replace it, or you add water or whatever like doesn't work in it. But in like one optimal scenario, you would just build it so that it's self-sustaining and you can just watch it and care for the one eternal living creature you put in as your Tamagotchi pet, something like that. Yeah, I hope that was an explanation that is understandable. I don't know. There are so many ideas in my head of what all I want to do into it, so it's hard to just like break it down fully. Yeah. I was just thinking if there are other parts of it that I thought about that might be cool. For now, as a first step though, I only will do one plant, one creature, probably nothing procedurally generated, and just build just make it so that you can place it on terrain and then have a life cycle with it. So the plants will drain resources from the soil they are put on, the creatures eat the plants, everything dies, and soil gets recreated, and then somehow water cycle and light source or something like that. Just very simple life cycle with just 2 elements. Oh, 3, like the ground, the plant, the animal. And if I have that going, then I can think of how to, you know, go further with the project. Because I think that is kind of a reachable goal where everything else is just daydreaming and way too much effort. Connecting a signal via code. You can connect the signal via code instead of using the editor. This is essential. Necessary. How did I not read that word? This is necessary when you create nodes or instantiate scenes inside of a script. Oh, true, because it's not hard connectable. Because it's not the general setup. Hmm. 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 Let's use a different node here. Godot has a timer node. That's useful to implement skill cooldown times, weapon reload, and more. Head back to the 2D workspace. You can either click the 2D text at the top of the window or press Ctrl F1. Oh, okay, yeah. The general main tabs, I see. In the scene dock, right-click on the Sprite2D node and add a new child node, search for timer, and add the corresponding node. Your scene should now look like this. With the timer node selected, go to the inspector and enable the auto start property. Click the script icon next to the Sprite2D to jump back to the scripting workspace. We need to do 2 operations to connect the nodes via code. Get a reference to the timer, call connect method on the timer timeout signal. To connect to a signal via code, you need to call the connect method of the signal you want to listen to. In this case, we want to listen to the timer's timeout signal. We want to connect the signal when the scene is initiated, and we want to do that using the node _ready function, which is called automatically by the engine when a node is fully initiated. To get a reference to a node relative to the current one, we use the method getNode. We can store a reference in a variable. There were some rules I heard that you should never use your parent nodes, only your child nodes, something like that, I think. And I also saw this be used differently. I think you can just do % or something instead of the get node as a shortcut, and then you can do on ready so that the variables you can also define in the members part and don't need to do it in the ready part. The function get node looks at the Sprite2D's children and gets a node by their name. For example, if you renamed the node to blinking timer, the editor would have to change the call node to get node blinking timer. We can now connect the timer to the Sprite2D in the ready function. Timer timeout connect on timer timeout. And I think here we are free how we call our methods or name our methods, right? And just this part is what's usually done by the UI. The line reads like so. We connect the timer timeout signal to the node to which the script is attached. When the timer emits timeout, we want to call the function on timer timeout. That we need to define. Let's add it at the bottom of our script and use it to toggle our sprite's visibility. By convention, we named the callbacks method. Yeah, we had that before. This changes the visibility. Okay, If you run the node 2D scene now, you will see that the sprite blinks on and off at 1 second intervals. Complete script. Okay, I'll like this more probably than the UI connected. Custom signals. This section is a reference on how to define and use your own signals and does not build upon the project created in the previous lesson. You can define custom signals in script. Say, for example, that you want to show a game over screen when the player's health reaches zeros. To do so, you can define a signal named died or health depleted when their health reaches 0. Health depleted. Okay. As signals represent events that just occurred, we generally use an action verb in the past tense in their names. Yeah, okay. I would probably do something like health value changed. Oh, but maybe you don't want to send it too often and don't handle all the signal processing and only want specific signals for efficiency, maybe. Your signal works the same way as the built-in one. They even appear in the node tab and you can connect to them like any other. To emit the signal in your script, call emit on the signal. Sure. A signal can optionally declare one or more arguments. Specify the argument names between parentheses. Nice. Probably it can also define the return type, because we could do that here, I think. Oh no, return type, it's a signal. What am I talking about? Return type makes no sense. None at all. This is just to add the parameters, not the return type. Okay, yeah. I was thinking more of an observer pattern where it's an explicit function call and only after returning you continue. But I think this is just detached async signals, right? So no return type, just one way. Where were we? Here. The signal arguments show up in the editor's node. Oh, we saw that. Wait, no. We saw this. The signal arguments show up in the editor's node doc, and Godot can use them to generate callback functions for you. However, you can still emit any number of arguments when you emit signals, so it's up to you to emit the correct values. Okay. To emit values along with the signal, add them as extra arguments to the emit function. I think this is fine and manageable, but I still would wish that I could just fix it and I can only use it like that. Let's read the summary. I'm kind of done with reading. Any node in Godot emits signals when something specific happened to them, like a button being pressed. Other nodes can connect to individual signals and react to selected events. Signals have many uses. With them, you can react to a node entering or exiting a game world, to a collision, to a character entering or leaving an area, to an element of the instance changing size, and much more. For example, area 2D representing a coin emits a body entered signal whenever the player's physics body enters the collision shape, allowing you to know when the player collects it. In the next section, you'll create a complete 2D game and put up everything you learned so far. Oh, why is there so much additional information? Interesting. Maybe there's actually interesting stuff for the signals. Okay, I recall that if I have questions for some of the things like signals or anything we had before, I'll recheck the documentation and maybe find this stuff directly and get like some background information if I get stuck with something. Let me check this. I told my mom earlier that I don't have time right now, but tomorrow would work. So let's check if she responded. But she did not. So I'll just assume I need to get up early and she has time. I don't know. Okay, first game. That's too much. I don't want to read it. So we're gonna skip through it, just read the notes and see if something is interesting. This was an introduction. Okay, not that note. Pre-requests, contents, creating, resolution, viewport. Wait. Oh, okay. Other stretch options, canvas, expert keep. This ensures the game scales occasionally different size screens. All details we don't need. Organizing, we have our own way of organizing. Creating a player scene. Sprite animation, new sprite frames. I think we all learned that in the tutorial too, but later I probably don't want to use, right? Because I want to generate the world procedurally and not with tiles, and I don't want it to explicitly create the collision shapes and sprite shapes, because they should be generated from input properties, right? So you set kind of how many bones or legs or whatever, and then the rest should be generated from that. Yeah, I have no idea if that kind of works out with the engine or not. If this is your first time encountering GSGN, no, we don't need to delete that. If you're using C#, you won't use it. We only mapped one key to each input action, but you can map multiple keys. If you've never used a vector math before, nope, we have. Tip. This is that's the shorthand. $sign is shorthanded for get node, so in the code above, this is the name instead of that. Dollar returns the node at the relative path from the current node, or returns null if the node is not found. Since the chart it's found. I think you can even with this do path, right, and go 2 down or 3 down or something like that. The delta parameter in process function refers to the frame length, the amount of time that the previous frame took to complete. Using this value ensures that the movement will remain considered in frame rate. Yeah, I should check that definitely. Process versus physics process. Click run current scene and confirm you can move the player around the scene. Attempt to call function play in base null instant on a null instant. This likely means that you spelled the name wrong. So that is not actual actual compile time. No, pre-compile time. Linter check. Interesting. I hope I can autocomplete though. I would need that. Let's copy that to underscore process versus physics process Godot 4. We'll read that in a bit. The Boolean assignment in the code above are common shorthand for programmers. Since we are doing a comparison test Boolean and also assigning a Boolean value, we can do both at the same time. Consider this code versus the one-line Boolean assignment above. If this, that, else that. Oh, okay, yeah. Standard stuff. I wonder if they have inline if statements, so if I also could do more complex stuff and directly write this question mark something double point something like in other languages. A common mistake here is to type the names of the animations wrong. The animation names in the sprite frames panel must match with your type in the code. If you named the animation walk, you must also use capital W. Yeah, I will define any string as a constant, definitely. If you're using an external editor, we will. A bug currently prevents Godot from doing so. You will be sent to the external editor, but the new function won't be there. In this case, you need to write the function yourself into the player script. Oh, that's why it won't work with the signals. So when we do a new signal and double click it from the UI, it won't, because it's the wrong editor, it won't create it. And in the Godot engine directly, it probably opens the scene file and adds it there. Okay. Disabling the area's collision shape can cause an error if it happens in the middle of the engine's collision processing. Use setDeferred tells Godot to wait to disable the shape until it's safe to do so. Okay. Okay. That's so many comments. Oh, I guess this is a direct page on Git, right? And that's how they do the docs. So this is literally the comments in GitHub. Creating the enemy. Yeah, I saw that before. We'll learn that again. Ready, play. Yeah, the play also is interesting to me. But maybe we can do that then in code and control click on it. Because it doesn't play the thing once, right? It repeats it, kinda. It's more of saying, this is our current animation, rather than start playing it right now once, which is what I would expect from play. Sprite mob. Oh, that's just selecting. Okay. Don't care for that. We are close. We are close to finishing this, and then we can do a short break and then do the YouTube video. Main game scene. Timers, marker, spawning mobs, path to D. And then I think there was a path following thing too, right? Yeah, you draw a path. Oh, draw the path in clockwise order. All your mobs will spawn pointing outwards instead of inwards. Interesting. Why pi? In functions we correct in angles, Godot uses radian, not degrees. Pi represents a half turn in radians, about. There's also a tau, which is equivalent to 2 pi if you are more comfortable working with degrees, you can... Nah, we'll stick with that. Testing the scene. If you had already set another scene as a main scene, you can click that and set that. Okay. Heads up display. Canvas layer. Are they loading a font here? Fonts load. Okay, they are loading a font. Anchors. Control nodes have a position and size, but they also have anchors. Anchors define the origin and reference point for the edge of the node. Standard UI building. Messages start button. When you need to pause for a brief time, an alternative to use a timer node is to use the scene tree create timer function. This can be very useful to add delays, such as in the above code, where we want to wait some time before showing the start button. But that's probably blocking, right? In game over, we need to call the HUD function, show game over. Yeah, I don't fully get if this is awaiting, it's blocking, right? So if we call that from any thread, nothing else would happen, right? And the game would just be stuck. So I'm not sure how this works, but that's something that then I would need to try out and see what's actually happening. But it's good to know that we can create timers right away. And I hope with this they will also be deleted afterwards, but I mean, it should be like that. HUD to main. In game over, we need to call the corresponding HUD function. Okay. Remember to remove the call to new game from ready if you haven't already, otherwise your game will automatically start. Removing old creeps. Okay. Finish up. So close to getting to the next tab. Finish up. We have now completed all the functionality for your game. Below are some remaining steps to add a bit more juice to improve the game experience. Feel free to expand the game with your own ideas. The default gray background is not very appealing, so let's change the color. Yeah, color rect, sound effects. Sound and music can be the single most effective way to add appeal to the game experience. In your game's art folder, you have two sound files. House in the Forest Loop .ogg for background music and gameover.waf for when the player loses. Add your audio stream player notes. Yeah. Music play, music stop, death sound play, keyboard shortcuts. Since the game is played with keyboard controls, it would be convenient if we could also start the game by pressing a key on the keyboard. Start game, shortcut, event. Oh, we map the input to the action start game. Sharing the first game. If you want people to try out your game without having to install Godot, you'll need to export your project for each operating system you want the game to be playable on. See exporting project for instructions. After exporting the project, compress the exported executable and package file to a zip file, not the raw project files. Then upload the zip file to a file sharing website. Okay. We don't need the 3D game part. So I think we're done. Those look like things that might be interesting, but I am done with reading for now. So we'll just keep it here and see if something is appealing and interesting. I did have this open though. Processing delta is called every frame and its frequency can vary depending on the frame rate. Physics process delta is called at a fixed frequency matching the physics tick of the game engine, which by default is 60 frames per second. Oh, so the delta is there for a time, but the delta is basically always the same. The delta parameter represents the time elapsed in seconds since the last frame. It helps ensure that the updates occur in a consistent rate regardless of frame rate variations. Similar, the delta parameter here indicates the fixed amount of time between physics frames, ensuring consistent physics behavior. Okay. Where's the answer to the question? When should you use? I refuse to read. It's called every frame, fixed frequency. It's important to choose the right function based on what you need to achieve in your game for smooth gameplay and accurate physics simulation. I guess I need to read it. Use when you need to update something on every frame regardless of the physics. This is where you put your code for anything that doesn't require precise synchronization with the physics engine, such as animating sprites or UI elements, handling game logic that isn't physics related, updating non-physics game state. So anything not position. Moving objects using the physics engine, checking physics interactions like collision, applying forces or impulses to physics bodies. Okay, I think I kinda get it. This is just only physics stuff. And probably you don't want to do too much in here so that, because this runs more often, so that this stays efficient, and then everything you just put in process delta rather than in process physics. At least that's my interpretation of it now. Okay. Yeah. Let's do this. Skip this. And I think I need to fix audio stuff. Do I want the music to keep running? Huh.
Setting up a projectile-based 2D.
Okay, but it looks kind of fine loudness-wise.
Doing it using a 1-bit platformer pack by
just not for me.
Which you can get off of itch.io for free. So I'll put the link to this art pack in the description, and we'll be using it to set up some basic projectile mechanics inside. Godot. So for this project, I'm going to be using version 4.3 of Godot, which is in its third beta. Most things will be consistent regardless of version, but one difference is going to be using tile map layers instead of the tile map node. So let's go ahead
Okay, I
and
think this
create our new
works.
project. I'll call a project something like Projectile Platformer 1-bit tutorial.
So I should be set up to start that now, and I'll just like play it and then follow the process and step by step do the entire thing. But I need to go pee before that. Which means we'll go to break screen and I'll be back in a second. I am back. The question is if I want to have the music in the background or not. But I think I'd rather not, maybe. Okay. Yeah, I think that's all, so we can start. Hello?
I'll choose my folder for tutorials.
Oh my god. Can you please do this?
Hello everybody, Chris here. In this mini-series, I'm going to be showing you guys the basics of setting up a projectile-based 2D platformer inside of Godot. And we're going to be doing it using a 1-bit platformer pack by Kenny.
How am I unable to find it?
Which you can get off of itch.io for free. So I'll put the link to this art pack in the description.
Huh? Okay, we'll just search for that. Itch. It's so quiet now that the music is not playing. I think I found it. I could have also just typed the link, but you know, too much effort. Okay, let's download. I think I did download. Godot. And then place it here. You'll be able to see in a second again. Extract. Okay. Okay, we have that extracted now.
And we'll be using it to set up some basic projectile mechanics inside Godot. So for this project, I'm going to be using version 4.3 of Godot, which is in its third beta. Most things will be consistent regardless of version, but one difference is going to be using tile map layers instead of the tile map node. So let's go ahead and create our new project. I'll call a project something like projectile platform.
Okay, new project. The classic. My first game. My first game.
Former 1-bit tutorial. I'll choose my folder for tutorials and my computer, and we'll just use the mobile vendor. Our graphics are about as simple as they can get. So inside of our project, we're going to need to import that art pack. So I'm going to, in the bottom left for file system, going to right click on the resources folder and create a new folder. So I would generally call my folder something like art or assets. So I'll just make it art here. And I'll right click to open this folder in File Manager. Okay, and navigating to where I have the 1-bit platformer pack downloaded from the website, we can either use individual tiles or just the packed tile maps. So for the project, I'll use the transparent packed version of the tile map. Packed meaning there's no spacing between the tiles, and then transparent means instead of a black background, we just have a transparent background. So we can actually set the background color easily to be whatever we want, and we don't need to worry about filtering out the black pixels or anything like that. So let's copy and paste this into art. I might even create another folder inside of here and say something.
Okay. I'm there too. So he wants us to copy tile map, monochrome tile map. 1 second. Monochrome tile map. Transparent packed. I think it's that one. Copy that, and then it should go into the my first game assets. Okay.
Something like Kenny 1-bit platformer, just to know where it came from, and put this in. And let's copy and paste the license into there. So of course, license-wise, you can see the art, of course, is Creative Commons 0. So you can use it in educational or commercial projects. So it's great for stuff like what we're doing here. Let's jump back into Godot.
Okay. License copy. My first game, assets.
Now, so back in Godot, the first two things you're probably going to do are start putting down a tile map and creating a scene for your playable character. We'll do both in the first part of this series. So I'll start with the tile map. Let's create a new 2D scene, and I'm going to rename this to be level 1. I'll save it to the project, so we might have a levels folder inside of here, so I'll just call this levels. And in levels, I'll save level 1.
That was a bit quick. Resource. Here we want levels. And then there we want level 1.
Now note in Godot, if you don't know already, file names are generally lowercase separated by underscores. So level _1.tscn. Let's save that there. And now our level is going to need a tile map layer. So if we search tile map, you'll see that tile map is being done.
There was something that there's a shortcut, right? Control C? No. Control Shift C? Control S? Control... Damn it. Control A. Wait, always... Oh, when I click, I always do rename. Okay. Okay.
Deprecated in 4.3. Of course, it's still going to work for a while. I don't know when they're actually going to finally remove that. But the new way of doing tile maps is going to be using tile map layers. So it's not actually all that different, except instead of having one tile map node and then layers over here in the inspector, you just have a different node for each of your layers of your game map. So you'd probably have like a ground layer, a background layer, maybe like a sky layer, like foreground, background, that kind of stuff. And you would just have a different node for each of those in the hierarchy instead of everything being condensed into one tile map node. So for the tile map layer, we're going to need a tile set resource. So note, you don't need to create one for each layer necessarily. You can just create one new tile set resource, and you can save this to the project and then reuse that across different nodes and different levels as well. So I'm going to right click this and save it.
Okay, so this is the tile set for everything, right? Interesting.
Let's say that since basically tile sets are going to be used exclusively on our levels, that we could create another folder inside of here, and I'll call it tile sets. And inside of here, we'll say Kinney 1-bit platformer, and automatically the extension will be .tres. So we'll save that there. So if we click on our tile set,
Any 1-bit tile set, save. Okay.
We'll see a bunch of different subcategories in the menu here. We'll come back to that in a second, but more pressing at the bottom of our screen is the tile set menu option here. So we want to switch to tile set to set up the tile set, and when you're drawing onto your 2D level, you would switch to tile map mode. So we need to be in tile set so we can set it up. Let's go find our...
But this is the same layer, right? So there's probably no separate... Oh, this is not directly the tile set. But if I not select anything here and just do this... Okay, yeah, this works. And now it doesn't have the tile map, so I can directly work in this. Probably just more effort. For some reason my screen is flickering now and then. I don't know why. How do I... Okay, mouse wheel to move around. Whenever I stop dragging, then it flickers. Weird. Okay, understood. We go here, we go there, we do this. And go back here.
Monochrome tile map transparent packed.png. I'm going to pop this in here to tiles. And in recent versions of Godot, you can just automatically create the tiles. So I'm going to hit yes to that. And all of these spaces are going to automatically be recognized as 16 by 16 tiles. And you can see because of the transparent version of the tile set, there's only one color here. So in 1-bit, you would have generally black or white. Some games like to add red to that mix, but 1-bit would just be on or off, so black or white. And we can use these for basically creating our game levels, and then these sprites down here can be our characters and enemies, as we'll set up in a bit. Okay, so if we were to switch to tile map mode, you can select these tiles now, and when you have it selected, you can left click somewhere. As long as you have tile map layer selected, it'll place it onto that layer. Now you might notice that these pixels are kind of blurry, so we want to change that in project settings. Let's go up to project settings.
How do I do side scrolling? Usually you can press like scroll normally, then side scroll with control. But now how do I do sides? Oh, okay, shift additionally. So control up, down, shift left, right. I see. And then probably the same here. Okay, I need to get used to that. That's not what I usually know as my controls. Okay, project settings.
And then down to rendering textures and change linear to nearest and hit close. You basically want to do that for every pixel art game. so that all of your pixels render much clearer as they are intended. Now you can build out your ground tiles by clicking on each one you need and left clicking, and then okay, you need to go across, so now you use the across tile, you click the corner tile, you go down like this. But that can get a little bit tedious, and if you recognize an obvious pattern here, then a better way is to create a terrain set. So in tile map layer, under the tile set, the Kinney 1-bit platformer, let's expand terrain sets, add element, and
okay, in tile map layer. I might have not paid attention and just drew too much. I wanted to finish the full thing. Physics terrain. Wait, but it's part of the tile map thing, right? So if I deselect and open this, it also has the terrain. Okay. And here it's just the sub part of the tile set. Damn it. Can I undo that? Oh, I can. Nice. Okay.
expand terrains.
Add expand terrains.
Add element. So for each set that you want to basically match with each other, different tiles that go together of the same type, you're going to want to give it a name and then a color. So I'll call it dirt and just leave the color the default brown because, I mean, it's dirt, it makes sense. Mode we can probably just leave at match corners and sides for now. So in order to add tiles to the set and then create a bit mask so that it knows which tile to place in which location automatically, we want to go to the tile map window at the bottom and then go to terrains. So in order to define which tiles are in this dirt terrain set and then to assign a bit mask to it so it knows which tile goes in which location with reference to the other tiles, let's go to the tile set window at the bottom. And we want to go to paint and then select a property editor, terrains.
Wait, but didn't it just say I should go to tile map and terrains? Oh, that's probably for drawing, right? But for creating it and have something to draw here, I probably do it in this one. And then paint, terrain. Maybe I didn't save this yet. Why is it not called dirt?
Select the terrain set 0, and then we'll
Shouldn't it be called dirt? Maybe not. But it's the same. Oh, wait, here it's now dirt. Oh, because it could be more sets and these sets are not named. If I do this, I would have a second one. Okay, so the first and then dirt. But why would I need several sets? I don't know.
choose dirt here. Okay, so basically find all the tiles which you would consider to be dirt, and I would say that's these 9 right here. And then left click, hold, and you can drag over each of them until they're lit up white instead of grayed out. And then once that's done, you can click on them and you can start assigning a bit mask. So if I left click and hold, you'll see that this makes the squares light up that.
I think we need to zoom more. Okay. Damn it. Oh, okay. Right click removes. Fine.
Brown color for dirt, and basically with the bit mask for terrains, you want to tell it which parts of the tile are fully defined as dirt, as opposed to the edges, which are only partially dirt and are probably adjacent to either nothing or a different terrain type entirely. So if a part of the tile is completely enveloped by dirt, then we want it to show as dirt. So that's going to basically look like this in the end. All of these border bitmask squares are going to be left blank. And the result of this is it'll know which tiles to place adjacent to each other, so that we know which ones are facing outwards to non-dirt and which ones are facing inwards to another dirt tile. So if we go to tile map now and we click on terrains, we select dirt here, and then we can start drawing. So I'm going to left click hold, and you'll see that it will automatically change the tiles to be...
Wait. That was too quick. Why is it looking dirt?
Select dirt here. And
but it looks different for me.
Drawing. So I'm going to left click hold, and you'll see that it will automatically change the tiles to be the correct dirt tile based on whatever's adjacent to it. Now, it's not perfect with just these...
Because we're missing inside, right? Yeah.
In cases like this, where you just have like one tile sticking out, it's not going to fill in the gaps perfectly. In fact, in this case, I think it needs to be at least 3 tiles wide for the tiles to...
Interesting. When I just move out, it's the corner, but when I move in... Oh, not on this side. On this side, when I move it out, it's different from drawing in. But I guess if we... Oh, it can't do it for 2. Though it should be able to do 2, like here. What? Okay, so it has some flaws, I guess. But it's still fast enough to then go into details maybe and can fix stuff like this, right? Yeah, I can. Okay.
Sign, but we can quickly just kind of draw on our tile map and get at least a decent...
So if that is that mode, what is this? Not what I expected. Path mode. Paints the terrain, then connects it to the previous tile painted with the same stroke. Okay, I don't understand that part. Connect mode paints a terrain, then connects it with the surrounding tiles with the same terrain. Okay. I think we'll just use that one, and if I ever need the other one, I'll probably find out in some tutorial.
Results. So we can kind of just go around the edges and get a pretty okay result. So we can see, of course, that although it does a pretty good job of tiling with just 9 tiles, we can't cover every possible case. So in this square right here, there should really be like a corner piece here and one there as well. I think that's just a limitation of having a simple 9-piece tile set right there for the dirt. Generally, when you have a more robust tile set, you have a bunch of extra pieces for covering these kind of specific
inside corners.
Cases where you have like corners and stuff like that. But for this case, it might just mean that there might be some limitations in which shape we can create, which is fine. And yeah, let's just kind of do something like that for right now. Another thing you can do for quickly just kind of putting some tiles down is to use the line brush if you want to go from one point to another. Or you can use the rectangle shape and just
paint line. Yeah, that's helpful. Amazing. Incredible. Okay. Maybe do a rectangle out of this.
Just draw in a huge blotch of tiles. So I could just click here and create ground just like that. Instantly has all the top, left, bottom, and right tiles. And we could go up a little bit like that. Maybe the space needs to be a little larger. We can come back and kind of fix that in a second. And maybe we have this go on a little bit further to the right. Okay, so for this bit, I'll just switch to the pencil tool and get those left sides in there. And that's probably good enough to at least have some basic playtest space. So let's save the level, and I'm going to create a new scene for our playable character here. So click to add a new scene, I'll right click and change the root to a character body 2D. And then let's rename this to be
Didn't work. I wanted to move the add.
Save this scene to our project. Name this to the root to the level, and I'm going to create a new scene for our playable character here. So click to add a new scene, I'll right click and change the root to a character body.
Damn, I was too slow.
For our playable character here.
New scene.
Click to add a new scene,
2D scene.
Click and change the root to.
But why do it like that? Don't save. Can't I just other node and then go character body 2D?
A character body 2D, and then let's rename this to be player. I'll save this scene to our project. So in the root, I'll create a folder. I might call this something like characters, and then hit OK. And then inside of here, I'll create one called player and save it. So let's zoom in on our scene. We'll need a sprite to render our players. So right click on our player, add a child node, and search for sprite. So we could either use a sprite 2D node or animated sprite 2D node. I'll try going ahead with an animated sprite 2D first, since it contains a little extra features for playing multiple
It's so quick.
Texture.
Can barely hold up the speed.
So we'll create that. In the animated sprite, if we
and this needs collision, right?
Animated sprite 2D, we can see animation as a category. Animation. We want to add new sprite frames into here. So new sprite frames resource, I'll create that. And since this is a resource, we can save it into our project. I might want to do that so that it's separate from this scene and reusable.
Oh, okay. So if I don't save it, it's just here. If I save it, it's separate. I wonder why this is a special thing and the resource is not just a node below. Okay.
I'll right click and save as.
And we should do that in this case, I guess. Save as. And that would be...
And in the player folder, I'll call this player sprite frames.
Okay. Player sprite frames. I guess I put it in the wrong directory. Player, save, and then we will move this one here. And it still works. Seems to still work. Okay. I was feared the moving would break something.
So now we can expand this and add in our animations. So let's create a idle animation. I'll rename default to idle. And FPS, I think we're going to want something like 20. We'll figure that out.
Where did he get the new animation? So oh, he renamed it.
Create a idle animation.
Okay.
I'll rename default to idle. And FPS, I think we're going to want something like 20. We'll figure that out for sure in a minute. And
Dad, how did I rename the... Okay, idle. 20 FPS.
We're going to want something like 20. We'll figure that out for sure in a minute. And we want to add in frames from our sprite sheet. So I'm going to click on the Add Frames from Sprite Sheet button, and then we'll go to Art, Kenny Platformer, and the transparent packed.png. Open that up, and if we zoom in, we can see...
Wait, here you need to press Control to zoom. Why is that inconsistent? And I can't scroll here with other controls. Okay. What? Okay, here this is scrolling up down. Control is zooming. Alt is going up down. Alt Shift is going left right. No, Alt you don't need. Okay, Shift is left right. Up down as usual. Control is zooming in out. That's how I'm used to it. I don't know why they have it like this here, which feels like the standard to me. But then they don't have that behavior in the main canvas. But fine.
Basically the whole sprite sheet. So our frames are going to be 16 by 16. So on the right, I'm going to do 16 and then 16. So these are the frames for our playable character for the pack. So our character is around...
Did I do something wrong? Wait, let's do that again. Why is it different for him? Size 16 by 16. What is this then, the 20? Can I hover this? No. Oh, that's the column count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, okay. Column rows, okay. And then the pixel size is per element. Okay.
Here for this pack, as far as I can see, doesn't appear to have like an animated idle animation. So we can just use the first frame here, add frame, and that can just be our idle. And let's add in some other animations. So add animation, and we want a run animation. So we'll select from the pack once again, zoom in, and that is going to be here to here. So I'll add those frames in, and let's also add in a dad animation.
Damn. Slower, please.
It's going to be here to here. So
here to here. Isn't that a jump? And this is running. And this is jumping from a run. But we'll just follow the tutorial. We can improve later. Here to here.
I'll add those frames in, and let's also add in a dad animation, and I'm going to make
run. Okay, I don't like that I can't directly rename what I just created. Dead.
Make all of these 20 FPS. While I'm doing that, let's actually test the run animation. Okay, maybe that's too fast. Let's make it 10. Yeah, that appears more like...
I thought we do the dead now. 10. Where did he click? Here? 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 Oh, I see. We'll do now this, right? I can't directly type, can I? No. I can't have two. Oh, I hate that I need to click down there. Why isn't the focus on this element already? Actual run. And actual run will be Oh, I think it's just 3 is the actual run, and then this is for the jump. And the difference in the lines is just the attachment on the head, right? How do I get 4? Damn it. Okay, let's see this compared to this with the weird jump in the end. Let's change this to... How can I do 2 times? I want this and then back there. 1, 2, 3. Oh, I add them all, I see. Jump. I can't do F2 at all. It always renames on top. So I need to press double. Damn it. Okay, 10. And now we need dead.
What it's supposed to be. Okay, so 10 is actually the FPS for all the animations. And for dead...
But they don't have to have the same animations, right?
This one little frame over here. These actually appear to be other variations on the character. So very simple character, but that's okay. We'll add that in. Idle, run, and dead. And we can just reverse the direction.
I wonder if there's relevance to having the same speed.
Of the sprite when we need it to run left. So this at least gets us our minimum requirements. So another thing we need for our player is to add a collision shape 2D for the physics body. So the character body 2D is a physics body. So I'm going to right click, add child node, and let's...
1 second. I need to check something. Ah, okay. So 11 o'clock tomorrow. Okay. To the player, Control A, collision 2D shape. This I like, it's fully controlled with mouse. I just click here once and it works. But the sprite editing that you can't F2 and directly rename is really weird.
Let's get a collision shape 2D. So a collision shape 2D, you could either make it a rectangle, a circle, or a capsule. I'm going to go with capsule. And then we want to adjust these handles right here until the capsule matches our character. So let's shrink the character or shrink the capsule until it basically... want to adjust these handles right here until the capsule matches our character. So let's shrink the character or shrink the capsule until it basically matches our character. Okay, so regarding the position of the sprite versus the collision shape, generally what I'll do, partially for sorting reasons, is to take all of the characters and position their 0, 0 position. That's where the axes meet, the 0, 0 position, and make that about where their feet are. So I'm going to move the character up to, I guess we'll just say right there, yeah. And move the collision shape as well. So to do that, I'm going to move the character up to 0, 0 position. And then we want to adjust these handles right here until the capsule matches our character. So let's shrink the character or shrink the capsule until it basically matches our character. So I'm going to move the character up to, I guess we'll just say right there, yeah. And move the collision shape as well. So
wait, why can't I? Oh, okay.
to do that, their feet are. So I'm going to move the character up to I guess we'll just say right there, yeah. And move the collision shape as well. So to do that, you hit W to go to move mode or Q to go to selection mode. So in W move mode, you can just reposition it, and Q to select between the different elements on the screen.
But I was able to move it, or maybe otherwise I can't. No, I can still move it. Probably because it's the only logical thing you could do with this thing.
So W move, and just kind of make it something like that. Okay, so we have a collision shape for our character. We might even want to make it a little bit smaller if we're also going to be using this as the hitbox. So just kind of favoring the player by making a smaller hitbox. And then we position that down there. So if like an arrow projectile happened to hit the ears, we just wouldn't count that as a hit until it hits this blue circle here. Okay, so let's put the character into level 1 for right now. So I'm gonna
first I want to check how, if I play the jump animation now, I see. Run, I see. Dead. Can I individually place those? No, I can't, right? Because this to me needs an offset to be, damn it, to be, oh my god, here. But I think I can't. That would be done in the sprite thing. Okay. Save level.
search the file system for player.tscn and add it to the scene, drag and drop. Okay, now we want to hit W to move it, and we'll move our player to right around here. So we have our character in the scene, but right now it's not.
Okay. Why W to move it? Does make no difference. And it has no grid position, does it? No. I mean, here it kinda does, but okay. Oh my god. The controls are so weird. Okay. And let's put idle as the default so that we can see it here. Okay.
Not really going to do anything. We haven't attached a script to the character body 2D. So let's attach a script, and I'll just call it.
You're too quick. Here, there. Why is attached script not have a... Oh, because it's here. Does this have a shortcut? No. Okay.
Player.gd. Okay, so for our character script, and I'll
Okay, empty.
just call it player.gd. Okay, so for our character body.
Okay, so now if I create, yeah, it should open in Visual Studio Code. And I need to switch to the Godot profile. Oh, I need to specify the executable every time. Path to Godot for editor executable. user setting. I don't think that is where I want to save it, but we'll see. Okay, saved. And now just restart. At least the warning is not here. Okay, full screen. Show that. Assets, characters, levels, tiles. Okay. And then we'll do it like that and switch back and forth.
Body 2D. Whenever the physics runs on each frame, so physics process, we want it to move and slide based on our input or lack of input, and we want it to be affected by gravity as well. So I'm going to start by implementing the function underscore physics process, and we'll just say move and slide here.
Okay. Function. Can I quicker autocomplete? Move and slide.
So on the physics body, we're going to be telling it to move and slide on every frame. If I hit play on the level scene, you'll
Oh yeah, we didn't debugger this, that, save. And then in the engine, I think I need to select the current scene. And now I should be able to launch it just from here. Okay.
You'll see that nothing happens there still. So let's get import from...
What did we see?
We're going to be telling it to move and slide on every frame. If I hit play on the level scene, you'll see that nothing happens there still. So let's get import from the user.
Let's edit the level real quick so that we are in the viewport actually. Oh, I can't move it like that. Damn it, I'm always pressing the wrong buttons. Wait, what is happening now? I don't want to move the tile map. Can I not tiles? Terrain? Can I not somehow select and copy? Ah, dirt. Picker, eraser, tiles. Oh, okay. And this is just not available in terrain. And now I can move it. Okay. And now with this, we can also move that one. Okay.
User to make the character move. So generally for doing that, you want to get an input vector, which is going to have your left, right, up, down movements. in one go using the input class. So if I say
Wait, let me check for a
direction,
second. Can you even see the coding? You can't. Hmm. Hmm. I could just keep the debugger open and by that move you over there. That seems fine. Okay, let's just keep it like that. Usually I don't have anything on the left side and just code like this, but I don't want to like move my camera and everything else now. So we'll just do it like that.
equals input dot get vector. Then here you would give it 4 string names for
var direction equals input get vector
for 4 different actions, which are going to be like left, right, up, and down. Now those actions need to be defined in project settings. So if we go to project settings and then input map, we can say left, right, up, down. And then for each of these actions, you
input map. Where is it? Oh, it's different tab.
settings. So if we go to project settings and then input map, we can say
this I like. I can directly type, add, no additional clicks needed. Okay, so and globals is where you can have singletons, I think. Input defaults. Okay.
left, right, up, down.
Mm-hmm.
And then for each of these actions, you can assign keys or controller buttons in order to trigger those actions. So I'll add A for left, D for right, W for up, and S for down. So there's your standard WASD movement input. So we hit close here. Now for the action names, which are string names, we could just type in left and then go right, up, down for that. But I'm not the biggest fan of that hard-coded approach. So for me, rather than hard-coding the names of the strings into the script, I will actually create a class that will hold all of the player input action names. And then
I like that.
instead. And I'll also make those
choose the right tutorial
exportable so that you can change them without going into your script. I just think that's a little bit of a better way of doing things. So let's create in the player folder. I'll right click, create a new script, and I'm going to call this player input or player.
Interesting. I could I mean, I can just navigate here and create a new file. That should work, right?
Input actions, actually. And it will inherit from resource instead of node. So let's create that.
Oh, interesting. Extends resource.
And double click into the script. I'll give it the class name, player
class name player
Your input actions, and that'll be much easier to reference this in other scripts like the player. And this will define the action names for the player input during gameplay. So we want to have at export var left, and then this will default to left. At export var right, which will default to right.
I think though I want I want this, right? So it inherits the type, and then we'll do right and up. Oh, that didn't work. And down.
At export var up, which will default to up, and then at export var down, which will default to down. Now, for each of these, you can optionally give it a string name typing. By default, when you just say equals a string, it's going to automatically make these strings. So a string name is supposed to be more of like a constant string that you don't change
to do the
during gameplay.
Double point colon thing.
Generally, a regular string you can change all the time, or
oh, but we want a special. Okay. So we want string name. Oh my god, I haven't coded in way too long.
Or append to it, add things. But for things
it does auto format.
String name
nice.
Makes more sense. So I'll use tabs to make this a little bit cleaner, and that'll basically be all we need from.
I disagree with that being cleaner.
We'll come and add extra actions for stuff like maybe a shoot button to launch projectile. So back in the player script, I'm going to at export of var, and let's just call this actions, but of type player input actions. And then with this, it's going to expose a field for this resource to be assigned in the inspector. And then we can use these actions instead of hard-coded strings. So it might seem like a lot of extra steps, but I think it just gives you a much cleaner result in the end, because now we can say something like actions.left, actions.right.
It's too much at the same time. Player input actions, and then here actions dot left. Right. Oh my god. Up. Down.
Right. Actions.up. Actions.down. And
left,
we
right,
don't
up,
have
down.
a hard-coded string here in this file. And that means that we can change it without accessing the player script. So if we click on player now, you can see the actions resource needs to be assigned here. So I'll create a new player input action.
I wonder if, like, I have the level here too, right? And I wonder where the assignment happens. So we instant stuff here, name player, and I guess here it should be added what we do with the assignment here. So if I now
and if we expand that, we have left, right, up, down string names, and these correspond with in the project setting.
Left, right, up string name and jump. I see.
Are left, right, up, down actions. So also, if we aren't using these.
Okay, so these strings must match exactly with the inputs, right? So for that to work later and not be confused, I should add jump. Okay.
Names in our actual project, maybe your project.
Wait, but I named them in capital case. So here's where the mapping then happens, I guess. Sub resource unnuke. Okay. I don't fully get it, but I kind of want to understand what happens in the background in the files that are created.
And you can just change them here, like left action. And then if you go to project settings, you can rename this to left action, and you can change it once again without needing to be inside the script. Also, stuff like that is more handy in projects where...
Oh, I think this just names it a capital letter, even though it is not. Which is weird.
But not everybody is really touching the code necessarily, and they just, you know, kind of want to be able to use the inspector here and just design things without messing with code. So that's basically what we need there. Because this is a resource, we can save it to the project and reuse it. So I'll right click, save our resource, and
Wait. Oh, so these are just the defaults for this resource. And now if we save it, we save whatever we've written in here and are no longer dependent on the defaults, which means that if can I extend it? If I go here and call it jump2 and save that, this will change. And now it's no longer overwriting, I guess. I see. So only if I reset it, it would be the default value. So I don't get why I would need to save it. If I save it now, I would just have another default, right? Because if I save that thing, it will be just like that, another resource.
I'll just put this in player. So player input actions.trs, save.
I guess if I want to have it for every player and want the default to be something else, I could save it. Player. What was the name?
Here. So player input actions.trs.
Player input actions. Let's see how that looks here. Player input actions. Okay, this looks similar to the level file. It looks like this, right? Yeah, I don't fully get why I would need to do that if it's specific in that moment already anyway. But that's fine. I don't need to get everything right away. So
yes, save. It's also handy to save resources because if you ever happen to delete your scene here, these files still exist in your project. So you're not starting from scratch. You can just
Damn, I should have just waited a second.
Access the same resources or load it into a completely different scene. Okay, so we have our direction.
Okay, so always save resources if I change anything special, because I didn't change anything special there, wouldn't matter.
For the input, we want to use that to basically change the velocity of the character. So how fast do we want a character to move? Well, that's going to be another @export. So let's say up here @export var move speed, and this will be a float, and we can set it to something like, I mean, it's kind of arbitrary. Let's say 50 to start and hit save. Okay.
With my setup, the problem is that I have shortcuts to like remove this directly, right? Camel case wise. If I do it like this, it doesn't work. So we'll definitely go with camel case if it lets us. Float 50.
Speed exported to the field here. Now this can be like -50 by default, which is kind of weird. So if we want to prevent our editors from being able to make the move speed a weird number like -50, let's revert that for a second, then we can change this to an @export range instead of just an @export.
Ooh.
And we can define kind of what value should be in that range. So you could say something like 0. The max isn't going to matter as much because we're going to make it set to or greater, so it can actually go above this even if we set it to 100. And then how much we want it to increment, which can be a floating point, so it could be like 0.1, or we could just say 1. And then the fourth parameter is going to be either hide slider or greater or less. So we want or greater, so that when we hit save and we left click and hold on this, it can go to 0.
Okay. I love this. Like all the other tutorials didn't go into these details, and I want to know exactly these things. That's exactly what I like to know about an engine. But it will take me forever to go through the entire video.
So that when we hit save and we left click and hold on this, it can go to 0 and it can go above 0, but it can't go below 0. So the move speed has to be a positive number now. And I think even if we type something like -100, it'll force it back to 0. So that's pretty helpful.
Did I do something wrong? The only difference is this, right? Or greater, speed 50. I don't get a slider anymore like I did a second ago, so I probably didn't save it. Okay, now I get it. I press and then click. Okay. So negative this 0. Maybe it automatically, if it's from 0.1, from 0 to 100, it thinks that it's a percentage thing and doesn't do the above, but if I click on top, I can. Interesting. Okay, reset to default, save it all.
Helpful for us. And now this is going up 5 at a time. We might not want that, so we could change this to something like 0.2. I wonder if that'll make it a little bit slower here for the increment. Yeah, so maybe that's a little better. So it goes up like 1 at a time instead of 5 at a time. So now let's set the velocity on the character body. So a character body already has a velocity property, and that has an x and y component. So we can say the velocity x is going to be equal to the move speed times the direction.x, and then move and slide will basically execute and move the character. Okay, so if we go ahead and hit play on our game, then we can see we can move our character left and right, but it's way too zoomed out.
We move so slow. Compared at least to him. Can I also quit this without quitting entire thing? Seems like. Okay, so maybe do the default of 100, 200, and then
and we'd also like a camera to follow our player around the scene. So if we go to the level 1, we can right click on the root, add a child node, a camera 2D, and then this camera 2D, you can see the purple box representing it, the lighter purple. It's way too big at the moment. We want it to be more of a section of our game level, not bigger than the entire game level. So to change that in the inspector, we go down to zoom. I'll set this to 3.
That was too quick. Inspector, zoom, 3.
And then that's a much more reasonable zoom level. You could even go further or less. And I think you can do like 3.5 too. If you want to. Okay, and then for focusing the camera on our player, we right click on the player, add a child node, remote transform 2D. So this pushes the remote transform position, or in other settings, onto the other node, which is our camera. So remote transform 2D, and we assign the camera. So now you can see that immediately the camera jumps to the player because that's where the remote transform 2D is. So if we have...
Interesting. I saw others solve this by dragging it below, but I found it weird that the camera would be below the player. So I like the remote transform thing. Pushes its own transform 2D to another node. So it takes the player transform and forces it on the camera. Okay. So what if we now remote transform, select the camera again? Is this not a conflict? Now it's at the tile map. If I put the tile map here, still on the tile map. If I select this again, still on the tile map. Reset. Still on the tile map? What? Didn't I... Maybe it's just the last thing that... Yeah, the last thing that was used maybe is the connection that's active. I don't know. But okay, we have the remote transform input on the camera layer. And now we are here. Okay.
Play. Not only are we zoomed in, but we also have a follow camera. Now, one last thing I want to fix for the video is to make it so that when our character moves to the left, our sprite actually faces to the left. And this is something we're going to want to do for all of our platformer characters. So this will get a little bit involved coding-wise, but hopefully by the end of this section, you'll see that this kind of setup will be really flexible and good for the long term. So first off, I want to go to player, and I want to create a node that's a parent of the animated sprite called facing. So I'm going to right click here and add a node 2D so that it has a position and rotation and scale. And I'll rename this to be facing, as in it's the node which controls which direction here. And add a node 2D so that it has a position.
Okay, I was a bit taken away by trying stuff. So we want a node 2D in the player. Oh, that's interesting. So that would be something here, right? If I want to do it myself and not... And then I would need to know these resource stuff. So I rather create those in the engine than trying to copy paste something here. Okay, so the setup of this I'll always do in the engine. Node 2D.
And rotation and scale. And I'll rename this to be facing, as in it's the node which controls which direction the character is facing. and then I'll take the animated sprite 2D and make it a child of that, so that this sprite 2D's scale is dependent on the parent. So if I click on the parent facing node and I go to transform, make sure X and Y are unlinked, and I set X to -1 for scale. Then that will make the character flip. Now,
well, it doesn't for us because we don't have the sprite default be run. Facing -1. Okay.
Now this also means other objects like a collision shape, if it's a child of facing, are going to flip from the right to the left. So you can use this to control hitboxes as well. Now for the facing node, we're going to want to attach a script to that. And this is going to be more of a component node, not necessarily specific to the player, but more specific to any platformer character within our game. So let's right click and add.
I really like the approach of really teaching how it would be nice to use it, instead of just taking this sprite and then see this transform and edit this scaling parameter, but just build a component that can be used anywhere. I wonder though if it's also possible to do it the other way around, because to me it would feel more natural if I could just drop this to any animation sprite and then facing would work for that. But maybe specifically for transformations, that's not the case how you would build it. So that would mean that if I have other transformation node things working like that, I would have to have them in a very deep tree, which would be kind of weird. But yeah, better to understand this pattern for now and then see how it applies, and maybe I like it or not.
Add a script. I'll call it facing, and I'll make it not in the player folder, but the characters folder.
Wait, why did it not? Oh, I pressed the wrong button. In the player, but the character folder. Yeah, because it's generally usable.
So facing.gd inherits from 2D
Okay.
2D. Now for this, we're going to want to get reference to a character body 2D, but not every character body 2D actually has a direction. If we open up the player script, the direction I'm talking about is the direction our character is trying to move. So we declared that in the player script as a local. We want to make that more of a script-wide variable or property now. And the way we would do that is by putting it outside of the function call. Now I don't want this to just be for the player script though, I want this to be for all platformer characters in the game. So I'll right click on the characters folder in our file system to create new script, and I am going to call it platformer character 2D, inherits from character body 2D, create, and we open up that script. I'll give it the class name platformer character 2D, so that we can easily reference that in our other scripts, like the player script.
And we don't need to do it with an scene, because it doesn't have useful visual components, right? It's just the scripting stuff we want to have, which is why we don't do it as a scene and just create the scripts, I think. And then it should inherit layer. Damn it. Layer. Okay. Oh, platform. No. Character body 2D.
And inside of here, we're going to have a reference name for character 2D.
Okay, so this is just our specialization of the character body class. Without a visual component, that's why it's down here and not up there. Player, no, platformer character 2D.
Inherits from character body 2D. Create, and we open up that script. I'll give it the class name platformer character 2D so that we can easily reference that in our other scripts like the player script. And inside of here, we're going to have a reference to the direction property. So var direction is a vector 2. Now if we open up the player script.
Why do we not export it?
Var direction is a vector 2.
Vector 2. I wonder why this not needs to be exported. Maybe because we don't want to edit it, right? Never in the UI, so it can just be like this. And then probably what he wants to do is, instead of extending this, we extend that, and then we don't need to instantiate the direction.
Now if we open up the player script, instead of setting the direction locally here, I'm going to remove the var part, and we're actually going to set it to the properties. But right now, the player script does not actually have the direction property because it's not a player character 2D. So we need to change the extends from character body 2D to platformer character 2D, which, if you remember, also inherits from character body 2D. So it's still character body 2D, just with the extra
specialization. Yeah.
And we might also want to give this a class name player if you want to be specific about it. Now, when we're creating the facing component, as I mentioned, we do want to apply it to the player, but we also want it to be able to apply to any other platformer character. So instead of referencing a player, we're going to export var reference a character, which is a platformer character 2D. So if you click on the facing script, we can assign the player character.
It's so quick. Platform character 2D.
So if you click on the facing script, we can assign the player, because it is a platformer character 2D, but we don't necessarily need to reference a player. It can.
But then why do we need to, couldn't we then not also have it separate and do remote transform? And then here we assign the sprite. And here we assign the player. Why is this different? Oh, because we moved the sprite, so we can't just apply the movement. The movement of the sprite is needed. And that does not reset the sprite. Great. Okay.
Just be any platformer character 2D, and that's important. So at the top here, I'll give it a class name facing, just in case we ever need to reference this script. And now what we want to do is, whenever the direction changes on our platformer character, we want to respond to that within our facing script. So a not great solution would be to use the process or physics process function, and then just check the direction on each frame. But a much better solution is to use a signal from the platformer character script, and then whenever that signal is emitted, we have a function activate inside of our facing script to update the direction or the scale on our facing.
How's it going? I really like the tutorial I selected.
Let's go to platformer character 2D.
It's exactly in the kind of detail that I want.
Whenever that's set to a new value, we want to emit a signal. Now we don't have a signal for that yet, so let's create one. So signal direction.
It's like, I would say it's really programming focused, which is perfect for my background. Changed. So it's really going into details and structures everything, and you know, not just the other tutorials when they did the facing thing, they just used the transformation positioning or scale and then tweak that. And here we added an additional facing node, we added additional nodes for the platform character in general, which has a direction property, and it's very technical, but yeah, exactly what I want. So yeah, so far I don't know if I can launch at the moment. I have this. So I learn a lot, but progress is really slow. But yeah, that's fine with me.
Changed, which is going to take a direction, which is a vector 2. So we're going to pass in that direction argument, and that will be received by our facing script later. So you don't necessarily have to use a setter property, but I think that's a pretty good way of handling this kind of thing. So basically, when we attach a setter function like this, set value, so like colon up here, and then set value colon, then whenever we try to set this property value, it's going to execute this code. So the code we want to execute is going to be direction equals value. So as it is right now, it would be exactly like we didn't have a setter at all, but now we add extra stuff.
Direction equals value. I guess something like this, but he will explain probably what I'm doing wrong. I feel that when I think when I first started, it felt slow going, but then once you know what it is and want to do with speed ups, oh yeah. I really hope. I feel like though the learning curve is not too steep for Godot. Like everything I saw so far was it just clicked, and I'm now. Maybe I forget, but as far as if I remember what it is, it will be easy to use and just apply to anything else. So yeah, I hope it stays that way and does not have like some really hard stuffs to understand like in other programming languages. So yeah, it kind of went well so far.
So when the direction changes, we want direction changed to be emitted using the new
value. I was applying Qt syntax.
Value.
Okay.
Now, we can also take this a step further. We only really want to change the value and emit the signal when the value is actually a new value. So as a precondition, we'll check up here that if the direction is equal to the value, we just return, and we don't set the direction and we don't emit the signal. That'll just reduce the number of unnecessary direction changed signal calls, because when we have direction changed, we expect the value to have actually changed. So that prevents it.
Oh, you need a colon? Wait, everything is like Python in and out, but the colon is necessary? Couldn't that be deducted too? But maybe you can do it inline. Return. Okay, that explains why you need the colon. Can I also do else inline? No, but probably I can do... I could do this inline. Okay. Interesting.
From just calling on every set, and then it'll only change when the vector is actually different. Okay, so
good, we did that.
Direction, which is going to run this code. If the value actually changes, direction changed gets emitted. So now in the facing script or any other script we want to respond to that, referencing a player character 2D, we can put our own setter function to connect to the signal whenever our character changes. So if the character is a valid instance, instance valid is instance.
Wait, that's not what I expected. Oh, that's even better than on ready. It's just when set, apply. Ooh, I like that. Instance valid.
Instance valid, and we'll check the current character. Then before we add the new character in, we want to disconnect from the old character's signals. So character dot direction change dot disconnect and on direction change. Now after disconnecting from an old character signal, we want to set the value to the character property. And then once we have the character set,
it's too fast. I can't follow. Okay. On direction changed. I think I want to rename them direction changed. I also want them to be camel case. And then probably down below we do something like func this what was it, post? No, pass. But this is wrong. Nothing. Okay. This is also not valid. For instance, function argument 1 should be int, but it is platform character. Okay, now it's right. And then we can continue.
We want to connect to that character's direction changed signal. So I'm just copy pasting this down here and we're going to do connect. At this stage, then
character new value, duplicate this, and then connects, right? Not disconnect. Okay, now we have the setup. Oh my god, I hate. Can I optionally do this? Okay. Because I do the spacing anyway, right? Because this is unreadable, I might as well put the other signs in there. Okay, so connect, disconnect, and if valid, connect that one. And that's the signal connection for the player. No, it's for generally any platformer. So any platformer we can now use, because it has a direction, we can now use in combination with the facing, and it will change the direction. And here we'll probably like compute something with the direction and say that if direction dot x bigger than 1, and then we do, I don't know, scale dot x 1, else scale dot x -1, something like that. Let's see.
Be a character set, but we're setting a new value here. So we want to disconnect old signals, and then we set the character on direction change. Now, after disconnecting from an old character signal.
Wait, what just happened? Did the browser reload and the video refreshed wrongly?
Once we have the character set, we want to connect to that character's direction changed signal. So I'm just copy pasting this down here and we're going to do connect. At this stage, there might already be a character set, but we're setting a new value here. So we want to disconnect old signals, and then we set the character. And once we set the character property in this script, we want to connect to the direction changed signal. Now we get errors because we don't have that callback method. So function on direction change, and as a parameter, we need the direction.
Oh,
vector.
true.
But I often like to put a P in front of the direction, P for parameter, so that we know that it came from the parameter specifically, and it's not a local variable, and it's not a property of the class. So on direction change.
Interesting. Do I want that? I'm not sure if my syntax highlighting might not just do it for me. Oh, we need those. The syntax highlighting doesn't. I like this in general, but I have it with like input or output usually. But this doesn't have that, right? So it could be like that parameter. I think I don't want to do that, but I don't know. I would rather name the general methods with something like this because it's a member. We'll just follow his convention for now, and I can stray from that at any point.
What do we want to do? Well, first we want to see if the x direction is actually 0, and then just ignore the rest of the function, because if the direction is 0 on x, that means that the character is not moving left and right, so there's no need to flip the direction of the facing component. So if p direction is equal to p direction.x is equal to 0, we'll just return. Okay, otherwise we want to take the scale.x and we want to set that equal to let's say the absolute value of the scale.x. So this.
But why would we return? Then we don't change anything, right? So we stay with the last direction we had.
This is the raw value of the x scale. Whether it's positive or negative, it's going to return a positive. And then we want to figure out what direction we should be making it face. So if we take the sine of the p direction.x, then that's going to give us either a plus or negative 1. Now it can also be 0 if this is 0, but we already handled that case right here. So we're not going to do anything with the scale when the x direction is 0, only when the character is actually trying to move to the left or actually trying to move to the right. So this is going to be plus or negative 1, and this is going to be the raw value of the scale. So when the character is facing left or moving to the left, this is going to make the scale, whatever it is.
Oh, I was confusing. I thought we wrote direction here, but we have scale here, so we keep the scale as it is, and then it makes sense to multiply with the sine. And the sine basically does the same as this, right? The sine is exactly this if clause. Sine of p direction dot x. Okay.
Raw value times negative 1.
Mm-hmm.
And whenever it's facing to the right, it's going to be the raw value times 1, which is going to give us our left-right facing direction. So hopefully this coding setup made sense. The reason we create a separate script for facing is so that it's a reusable component. We create the platformer character 2D class so that we can have certain aspects applied to different characters in our game without re-implementing them in every enemy script.
Mm-hmm.
And then we inherit from that script so that that direction is part of the player as well, but not exclusive to the player, because any platformer character 2D can now have that. So
that means that whenever I do a new, can I see the node type of this? Sub-resource. Character body 2D. But it's not, it's a platformer character 2D currently, right? Maybe just not reloaded, we changed this because we changed it in code. So whenever I create this, I can put a facing below that, and that facing directly handles everything. So if I set the direction on the player, wherever I do that, That will work. And because we do set the direction of the player here, this will automatically handle the facing for us. And the direction setting I could do in any kind of way I want to. And only when this changes in a way that the sign changes, we actually do something. No, that's not true. We do it whenever direction changed. So if we would want to optimize this, we could even go and change it so that it only sends the signal if direction actually changes or something like that, and cache the last direction. Okay. Let's continue.
We'll be able to easily reuse that for our enemies later on. Yeah, and hopefully this setup with a custom signal all makes sense. Signals just kind of reduce a lot of the unnecessary function calls you need to have so that you're not calling process to check on a variable every single second of the game, or millisecond even, but rather you're just waiting for something to change and then your code executes. It's just a better way of doing things. So if we hit play, we're going to have a character here. If I move to the left with A, you can see that it flips to the left, and then D will flip it to the right. So back and forth. And if the character's not moving, nothing happens, which is exactly what we expect. So to show what this is actually doing, if I expand the remote view, which is our...
The thing is though, isn't the facing scale always 1? So I should even be able to do it like this, right? I think at least. So this should still work. It does. Because it's not actually scaling in the sense of changing the speed or anything like that. Okay, it's just to have it like correctly. If we would transform the facing now and move that in a different position, then it would be weird because then the offset might be wrong. So we keep it, but I think it's not needed for how the setup works with this. The facing scale always be 1 anyway. Like 1 or -1. Okay.
Our current gameplay scene. Local is for the editor, remote is for gameplay. And we expand player, we can click on facing and see that the scale is set to -1. Now if I move to the right, the scale is set to 1.
Oh, wait. Shouldn't I see that when I do debugging too? Maybe I need to do more setup for being able to see that here. Breakpoints. Oh, active scene tree has not been requested. Inspector. Refresh. So I guess I don't need whatever is up there, and I need this. But I can also do breakpoints, right? Okay, then I need those. I see. And this is the inspection of the game at the moment. Oh yeah, I broken. And then I want to see the facing information. Oh, and that is down here. And then somewhere here there's scale 1. Ugh, but I need to refresh every time. Okay. But good to know. Now we get local. Player local facing forward. What?
And remember that remote is for gameplay.
Oh, remote is for gameplay.
Click on facing and see that the scale is set to -1.
Oh, and it's exactly the same, so it doesn't matter where I am. When I am on remote, it's the same route that I have here. Okay, so player facing and then -1. But here it does automatically update, which obviously is nicer than needing to refresh. I'm not sure if I can do something for it to auto refresh, maybe some setting somewhere. Okay.
Now if I move to the right, the scale is set to 1. And remember that as the parent of these child nodes, whatever happens to the scale affects what's down here. So we don't need to change the scale of the animated sprite to face left because the parent, the facing node, already does that for us. So this controls all of its child nodes, and if you need it to flip directions, you just make it a child of facing. So that should pretty much be a good setup for the start of this project, I think. I'll have a link in the description if you want to download the part 1 of the tutorial. And of course, on each part, I'll have the updated version of the project going all the way to the conclusion. And those will be on my Ko-Fi and Patreon pages. So if this tutorial helped you out, thanks for watching to the end. I've been Chris, and I'll see you in my future video content. Hello everybody, Chris here, and in this part 2 video, I want to continue working on our player for our 1-bit projectile platform. So the
question is, do I want to continue? It's been a bit already, so I might want to stop for today. Let's see if I want to play a game with a friend later, maybe. So if he already answered, maybe I'm a go. Okay, starting from now, he's free. I think I'll pause the video here. And continue there next time. I really love it so far. It's just working so smoothly, and I know that so far I have nothing really special yet, but I feel like I learned so much with this tutorial, where it really goes deep into structuring things, using more advanced stuff to do the simple things. Like, why would we do signals for just this switching of the face and do like 2 more classes just for that? But that's just good practice, I think. Yeah, so interesting. We slow down when I press W2 because then the direction vector is no longer scaled correctly. I mean, it's correct if we would add this back in, but because we don't, it's half the speed when I press that. Let's see, is that true? Yeah. Yeah, okay. Because if I just go right and then press up additionally, the speed in all directions is the same. So if I don't apply the Y movement and only go left and right, and I press that additionally, it gets slower in the left or right direction. Can I? Is there? Maybe. Normalized. Let's see. No, it still gets slower. What would it that I want to do? I think I would need to, because I ignore Y, just ignore this part or scale it up. Oh yeah, it shouldn't be scaled in that way. This should be double the speed. But yeah, that's fine. Oh, and also, don't we need to do that? Actually? I'm not sure if I missed that in the tutorial, but it should be like that if the speed ever varies. But maybe for the standard stuff it doesn't matter. It's so slow now. Damn it. But we're moving. Because the distance is always the same, assuming that we never have slowdowns in the physics process, this can be ignored, I think. We'll just up the default movement speed, but keep the delta maybe. I don't know. I just fear to follow the tutorial and then at some point it's wrong. Yeah, whatever. Anyway, I wanted to finish and not try other stuff. So remove that. Make this 100. Can I also, if I don't use it anyway, remove it here? No, okay. So it will just hint me that I don't use delta, right? Unused parameter. Okay. Oh, what? If this is intended, prefix it with an underscore. But I like the hint for now because I don't know if this was intentional or not. Okay. So let's start music again. And go to the ending screen. Where is it? Here. It was a lot of fun. The reading in the beginning was a bit tedious, but I think it gave me important information. And then the video I love. I think I couldn't have found a better one because it really goes deep into how I want to program stuff and all the structure I want from it. So yeah, I am really hyped to continue tomorrow. I was a bit sad that I didn't stream the last days because I was just checking out videos, was checking what I want to do, checking how in general Godot works, and so I just didn't stream and just watched YouTube. But now that I have this working and I can literally do all I want with it, setup wise, right? So I can see the video on top, I can see my program, I can switch to code, everything just works. So I'm really happy and hyped for continuing that tomorrow. I don't know at which time. I would hope to get up as early as maybe 10 and then help my mom at 11, so maybe at 12 I'll continue. But yeah, with that, let's go to the end screen. And then I'll be back tomorrow continuing right here. So thanks everyone for watching and bye.